Hello friends, now we'll start the second topic for the differentiation. That is the geometrical meaning of a derivative. Now let us start. Yes. Fix Q is in on that curve a plus f of a plus. Consider a point P on the curve f of x at x is equals to a. The coordinates of P are a f of a, let Q be another point on the curve a little to b, that is the right of P, that is to the right of x is equals to a, with a value increased by small real number h that is a changes to a plus h, and that's why the function also changes. It changes f of a plus h. Now we can calculate the slope of second line PQ, that is slope of the second line connecting the points P, a f of a, and Q in bracket a plus h f of a plus h by using formula for slope of second PQ, and that is nothing but the difference of y coordinate upon difference of x coordinate, that is f of a plus h minus f of a upon a plus h minus a. These are the x coordinates. That is just we find out the slope, and this is nothing but the definition of the first principle definition, and also it is called the gradient of the curve. Suppose we make h smaller and smaller, then a plus h approach a as h gets closer to 0, and q will approaches to the point P. That is, as h tends to 0, the secant converges to the tangent at P. Limit q tends to P, slope of secant PQ is equals to, this is nothing but the slope limit h tends to 0, f of a plus h minus f of a upon h is equals to f dash of a. So we get slope of tangent at P is equals to f dash of a. Thus, the derivative of function y is equals to f of x at any point P xy, that is x1, y1, is the slope of the tangent at that point on the curve. For example, if y is equals to x square plus 3x plus 2, then slope of the tangent at 3, 2 at the point 3, 2 is given by, that is the slope m is equals to dy by dx at the point 2, comma, at the point 3, comma 2. Here is that is the derivative of x square plus 3x plus 2 is a 2x plus 3. Replace x by 2. Therefore, you will get 2 into 3 plus 2, 2 into 3 plus 3, that is a 6 plus 3, that is equals to 9. This is the slope. Now next topic is derivative of inverse functions. We know that if y is equals to f of x is 1, 1 and onto function, then x is equals to f inverse y exists if f inverse of y is differentiable, then we can find its derivative example, consider f of x is equals to 3x plus 3. Then its inverse, f of x is equals to 3x plus 3 is equals to y, and that's why x is equals to y minus 3 upon 3. Therefore, f inverse of x is equals to, find out the value of x in terms of y, and f inverse of x, replace this y as x. F inverse of x is x minus 3 upon 3. Let g of x is equals to f inverse of x. That is x minus 3 upon 3. If we find the derivative of these functions, we see that ddx of f of x is equals to 3 and ddx of the g of x is equals to 1 upon 3. These derivatives are reciprocal of one another. Consider y is equals to f of x is equals to x cube. Let g is equals to f inverse of x. G of y is equals to x, and that is equals to cubic root of y. Therefore, g dash of y is equals to 1 upon 3 into y raised to 2 upon 3. F dash of x is equals to 3x square. G dash of y is equals to 1 upon 3 into y raised to 2 upon 3. Now ddx of g of f of x is equals to, by using the composite function that we have learned, that is a g dash of f of x into f dash of x. F of x means y, and f dash of x is 3x square. Therefore, you will get x square. Y is x cube and raised to 2 upon 3. Therefore, x square upon x square, and that is equals to 1. Therefore, ddx of g of f of x is equals to 1. Therefore, g of f of x is equals to g of x cube, that is equals to x. Therefore, ddx of g of f of x is equals to 1. At a point x cube on the curve, f dash of x is equals to 3x square and g dash of y is equals to 3 into 2 raised to 3 upon 2. 1 upon 3 into y raised to 2 upon 3. Therefore, the g dash of y is equals to 1 upon 3 in bracket x cube and bracket raised to 2 upon 3. That is 1 upon 3x square. This is the g dash of y. That is equals to f dash of x. Therefore, g dash of y is equals to 1 upon f dash of x. Again, this is very important theorem which asked in exam. If y is equals to f of x, is a differentiable function of x such that inverse function y is equals to f inverse of y exists, then x is a differentiable function of y, and dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0. Now here is a proof. The same dialogues are repeated here. Let delta x be an increment in x and let delta y be the corresponding increment in y. We know that delta y upon delta x into delta x upon delta y is equals to 1. This gives delta x upon delta y is equals to 1 upon delta y upon delta x, where delta y upon delta x is not equals to 0. Taking limits as delta x tends to 0 on both sides, limit delta x tends to 0, delta x upon delta y is equals to limit delta x tends to 0, 1 upon delta y by delta x, that is 1 upon limit delta x tends to 0, delta y upon delta x. As delta x tends to 0, delta y also tends to 0. Therefore, limit delta y tends to 0 of the delta x upon delta y is equals to 1 upon limit delta x tends to 0, delta y upon delta x. Since y is a differentiable function of x, therefore dy by dx exists, and limit delta x tends to 0 delta y by delta x is equals to dy by dx. Therefore, the RHS of one exists. Hence, LHS limit also exists. And limit delta y tends to 0 delta x upon delta y is equals to dx upon dy. Therefore, the equation 1 becomes dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0. Now the illustrative examples. These examples are not easy, they are tough. Find the derivative of the function y is equals to f of x using the derivative of the inverse function x is equals to f inverse of y in the following. First, y is equals to cubic root of x plus 4. Now we first find the inverse of the function y is equals to f of x. That is x in term of y. Y cube is equals to x plus 4. Therefore, x is equals to y cube minus 4. X is equals to f inverse of y. That is y raised to 3 minus 4. Therefore, dy by dx is equals to 1 upon dx upon dy. That is to differentiate this x with respect to y. Now, what is the derivative of y cube? That is a 3y square. That is 1 upon 3y square. Now the value of the y, that is the cubic root of x plus 4 bracket square. For x is not equals to minus 4. Therefore, dy by dx is equals to 1 upon 3 cubic root of x plus 4 bracket square. And that's why this is the dy by dx. Second, y is equals to square root of 1 plus root x y is equals to f of x. That is x in term of y. Therefore, y is equals to square root of x plus root of x. Squaring on both sides. that is y square is equals to 1 plus root x. Therefore, root x is equals to y square minus 1. Therefore, x is equals to f inverse of y. That is x is equals to squaring on both sides. Then you will get x is equals to y square minus 1 bracket square. Therefore, dy by dx is equals to 1 upon dx upon dy. That is equals to 1 upon ddx of y square minus 1. Now differentiate this. This is the power, that is a 2 times y square minus 1 into ddy of y square minus 1. What is the derivative of y square? Is a 2y, and derivative of 1 is 0. And that is equals to 1 upon 4 y in bracket y square minus 1. That is 1 upon 4 in root of 1 plus root x in square bracket a root of 1 plus root x bracket square minus 1. That is 4 in root of 1 plus root x in bracket 1 plus a root x minus 1. Therefore, 4 in root of 4 into root x into a root of 1 plus a root x. Therefore, dy by dx is equals to 4 root x in root of 1 plus root x. Now third, y is equals to log x. Every time find out x in terms of y. That is, we first find the inverse of the function y is equals to f of x. That is, x in term of y is equals to log x. Therefore, x is equals to f inverse of y is equals to e raised to y. Therefore, x is equals to e raised to y. Therefore, dy by dx is equals to 1 upon dx upon dy. Therefore, 1 upon dx upon dy is equals to 1 upon ddy of e raised to y. That is 1 upon e raised to y. Therefore, dy by dx is equals to 1 upon x. Fourth, that is, find the derivative of the function y is equals to 2x cubed minus 6x and calculate its a value. X is equals to minus 2. Now, given that y is equals to 2x cubed minus 6x, differentiate with respect to x. Dy by dx is equals to 6x square minus 6. That is equals to dy by dx is equals to 6 in bracket x square minus 1. Therefore, dx upon dy is equals to 1 upon dy by dx That is dx upon dy is equals to 1 upon 6 in bracket x square minus 1 at x is equals to minus 2. Find out the value of the y. That is y is equals to minus 16 plus 12. Therefore y is equals to minus 4. Therefore dx upon dy y is equals to minus 4. That is equals to 1 upon dy by dx at x is equals to minus 2. That is 1 upon 6 in bracket minus 2 square minus 1. That is 1 upon 6. That is 4 minus 1. That is 1 upon 18. The next is f and g be the inverse functions of each other the following table lists a few values of f, g, f dash. Now see this table. The values of x minus 4, 1, f of x 2 and minus 4, g of x, f dash of x, g of x is 1 minus 2, f dash of x is 1 by 3, 4. In order to find g dash of minus 4, we should first find an expression for g dash of x. For any input x, since f and g which holds for any two differentiable inverse functions, g dash of x is equals to 1 upon f dash of g of x. Now how this comes, that is, if we go f of g of x is equals to 1, therefore f dash of g of x is equals to f dash of g of x into g dash of x. This is therefore g dash of minus 4 is equals to 1 upon f dash of g of minus 4, and we will substitute the value. That is a g of minus 4 is a 1, and what is f dash of 1? F dash of 1 is 4. Therefore g dash of minus 4 is 1 upon 4. Next example. Let f of x is equals to x raised to 5 plus 2x minus 3. Find f inverse, f dash of f inverse at x is equals to minus 3. Now here is a f of x, differentiate it with respect to x. Then you will get f dash of x is equals to 5x raised to 4 plus 2. Now here we have, that is a y is equals to minus 3. Therefore f dash of f inverse at y is equals to minus 3 is 1 upon f dash of 0 that is, if we substitute, that is a y is equals to x raised to 5 plus 2x minus 3. If we substitute y is equals to minus 3, then the value of x comes to 0. Therefore, that is a f dash of f inverse at x is equals to minus 3 is equals to 1 upon f dash of f of 0. And therefore, its value is a 1 upon 2. Next. Derivatives of standard inverse trigonometric functions. Y is equals to sine inverse of x and the values of x lies between minus 1 and plus 1, y lies between minus pi by 2 and plus pi by 2 equals to also. Then dy by dx is equals to 1 upon in root of 1 minus x square, where mod of x is less than 1. Now we have y is equals to sine inverse of x. Therefore, we can write this x is equals to sine y. Now differentiate this with respect to y. Dx upon dy is equals to cos of y. Therefore, dx upon dy is equals to plus or minus in root of cos square y, that is a plus or minus in root of 1 minus sine square y. Therefore, dx upon dy is equals to plus or minus in root of 1 minus x square, and therefore sine of y is equals to x. But cos of y is positive. Where when y lies in first and fourth quadrant. Therefore, dx upon dy is equals to in root of 1 minus x square. Therefore, we have dy by dx is equals to 1 upon in root of 1 minus x square. Second, you have to remember this formula, that is a dy by dx is equals to 1 upon in root of 1 minus x square. This is the derivative of sine inverse of x. If y is equals to cos inverse of x, the values of x lies between minus 1 and plus 1, and the values of y lies between 0 to pi. Therefore, dy by dx is equals to minus 1 upon in root of 1 minus x square. Let y is equals to cos inverse of x. Values of x lies between minus 1 plus 1, and y lies between 0 to pi. Then x is equals to cos y. Differentiate this with respect to y, we get dx upon dy is equals to minus sin y minus in root of 1 minus cos square y. That is dx upon dy is equals to minus in root of 1 minus x square. Therefore, dy by dx is equals to dx upon dy, and that is equals to therefore dy by dx is equals to minus 1 upon in root of 1 minus x square. This is the dx of cos inverse of x minus if y is equals to tan inverse of x, x belongs to set of real number, and y lies between minus pi by 2 to plus pi by 2, then dy by dx is equals to 1 upon 1 plus x square. Now y is equals to tan inverse of x. Therefore, x is equals to tan y. Now differentiate this with respect to y. Therefore, dx upon dy, you will get sec square y. X is equals to tan y. Differentiate this with respect to y. Therefore, you will get dx upon dy is equals to sec square y. That is a 1 plus tan square y. That is 1 plus x square. Therefore, dy by dx is equals to 1 upon dx upon dy. That is 1 upon 1 plus x square. If dx upon dy is not equals to 0. Therefore, dy by dx is equals to 1 upon 1 plus x square. Fourth, if y is equals to cot inverse of x, x belongs to set of real number, therefore dy by dx is equals to minus 1 upon 1 plus x square. Y is equals to cot inverse of x, x is equals to cot of y. Now differentiate this with respect to y. That is the dx upon dy is equals to minus cosec square y. That is a minus in bracket 1 plus cot square y. that is minus in bracket 1 plus x square. Therefore dx upon dy is equals to minus in bracket 1 plus x square. Therefore dy by dx is equals to 1 upon dx upon dy. Therefore dy by dx is equals to minus dy by dx is dx upon dy is not equals to 0. Therefore ddx of, so by mistake it is a t, not t. Differentiation with respect to this is a x, not t. Fifth, y is equals to sec inverse of x then dy by dx is equals to 1 upon x in root of 1 minus, that is a 1 upon x in root of x square minus 1. Y is equals to sec inverse of x. X is equals to sec y. Here mod of x is greater than 1 and the value of y lies between 0 to pi, where y is not equals to pi by 2. Also, sec y is and tan y are of the same sign in first and second quadrant. Therefore sec y into tan y is positive. Now differentiate this with respect to y. We get dx upon dy is equals to sec y into tan y, that is sec y into sec square y minus 1. Therefore x into x square minus 1 dx upon dy. Therefore dy by dx is equals to 1 upon dx upon dy if dx upon dy is not equals to 0. Therefore dy by dx is equals to 1 upon x in root of x square minus 1. Now the last is cosec. You have to remember only the formulas from this. If y is equals to cosec inverse x, and mod of x is greater than 1 and values of y lies between minus 5 by 2 to plus 5 by 2, and therefore dy by dx is equals to minus 1 upon x in root of x square minus 1. X is equals to cosec y, mod of x is greater than 1, and the values of y lies between minus 5 by 2 to plus 5 by 2, where y is not equals to 0. Now cosec y is equals to cosec y and cot of y are have the same sign in first and fourth quadrant. Therefore, cosec y into cot y is a positive. Therefore, dx upon dy is equals to minus cosec y into cot y. That is minus dx upon dy is equals to minus x in root of x square minus 1. Therefore, dy by dx is equals to dx 1 upon dx upon dy. If dx upon dy is not equals to 0, that is 1 upon minus x in root of x square minus 1. Therefore, ddx of cosec inverse of x is equals to minus 1 upon x in root of x square minus 1. Now some important formulas. This is very important now. Some important trigonometric formulae for inverse trigonometric functions. Sin inverse of sin theta is a theta. By mistake it is a sin of sin inverse theta is theta. In the same way, cos inverse of cos theta is theta. Next is tan inverse of tan of theta is theta. Tan of tan inverse of theta is theta. Fourth one, cot inverse of cot of theta is theta. Cot inverse of theta is theta. Fifth one, sec inverse of sec of theta is theta. Sec of sec inverse of theta is equals to theta. Sixth one, cosec inverse of cosec theta is equals to theta. Cosec in bracket cosec inverse of theta is theta. Seventh, sin inverse of cos of theta, that is a sin inverse in bracket sin of pi by 2 minus theta, that is equals to pi by 2 minus theta. Next is cos inverse in bracket sin theta, that is a cos inverse in bracket cos of pi by 2 minus theta, that is equals to pi by 2 minus theta. Tan inverse of cot of theta, that is the tan inverse of tan of pi by 2 minus theta, is equals to pi by 2 minus theta. Cot inverse of tan of theta, that is the cot inverse of cot of pi by 2 minus theta, is a pi by 2 minus theta. Sec inverse of cosec theta, that is the sec inverse of sec of pi by 2 minus theta, And we can convert in the same trigonometry. One will be inverse and another will be in general. Cosec inverse of sec theta that is a pi by 2 minus theta. Sin inverse of x is equals to cosec inverse of 1 upon x. Next is cosec inverse of x is equals to sin inverse of 1 upon x. Cos inverse of x is equals to sec inverse of 1 upon x. 16. Sec inverse of x is equals to cos inverse of 1 upon x. 17. Tan inverse of x is equals to cot inverse of 1 upon x. 18. Cot inverse of x is equals to tan inverse of 1 upon x. These are similar formulas, you have to remember only. Sin inverse of x plus cos inverse of x is equals to pi by 2. This is very important. Tan inverse of x plus cot inverse of x, that is equals to also pi by 2. Sec inverse of x plus cosec inverse of x is equals to pi by 2. Now this is again important. 22. Tan inverse of x plus tan inverse of y is equals to tan inverse in bracket x plus y upon 1 minus x into 1. 23. Tan inverse of x minus tan inverse of y is equals to tan inverse of x minus y upon 1 plus xy. Now some standard substitution. This is also very important. That in root of 1 minus x square x is equals to sin theta or x is equals to cos theta. When we solve the problem, at the time we must know what are the particular substitutions we will apply there. In root of 1 plus x square x is equals to tan theta or x is equals to cot theta. Third, in root of x square plus 1, that x is equals to sec theta or x is equals to cosec theta. Fourth one, in root of a plus x upon a minus x, or in root of a minus x upon a plus x, x is equals to a cos 2 theta or x is equals to a cos of theta. This is very important. This is a typical substitution. The fourth one. Fifth, in root of 1 plus x upon 1 minus x or in root of 1 minus x upon 1 plus x, then x is equals to a cos of 2 times theta and x is equals to cos theta. Sixth one, in root of a plus x square upon a minus x square or in root of a minus x square upon a plus x square, that is x square is equals to a cos of 2 times theta and x square is equals to a cos theta. Seventh one, 2x upon 1 plus x square where x is equals to tan theta. 1 minus x square upon 1 plus x square, x is equals to tan theta. And these are nothing but the formulas, that is the sine of 3 theta and just like cos of 3 theta. That is a 3x minus 4x cube or 1 minus 2x square. That is x is equals to sin theta. This is 4x cube minus 3x or 2x square minus 1. Here is x is equals to cos of theta 11. 3x minus x cube upon 1 minus 3x square, where x is equals to tan theta. And next is a 12th one. Which is also given. That is illustrative example. Too much illustrative examples are there. Now we'll see all the examples. Using the derivative, prove that sin inverse of x plus cos inverse of x is equals to pi by 2. We have to prove that f of x is equals to pi by 2. Now differentiate this one with respect to x. Then what is the derivative of sin inverse of x? That is 1 upon in under root of 1 minus x square. And it's a minus 1, that is equals to 0. F dash of x is equals to 0 implies that f of x is a constant. That is, the derivative of constant is 0, therefore f of x is a constant function. Let f of x is equals to c. Suppose that constant is c. For any value of x, f of x must be c only. So conveniently, we can choose x is equals to 0. Therefore, f of 0 is equals to sin inverse of 0 plus cos inverse of 0. And the sin inverse of 0 is 0 and cos inverse of 0 is pi by 2. And therefore, c is equals to pi by 2, and hence sin inverse of x plus cos inverse of x is equals to pi by 2. Next, differentiate this with respect to x. Y is equals to sin inverse of x cube. What is the derivative of sin inverse of x? That is 1 upon in under root of 1 minus x square. This is dy by dx is equals to 1 upon in root of 1 minus x cube bracket square into ddx of x cube. And that is equals to 1 upon in root of 1 minus x raised to 6, 3x square. Therefore, dy by dx is equals to 3x square upon in root of 1 minus x raised to 6. Second, cos inverse in bracket 2x square minus x. Therefore, cos of y is equals to or directly we can use the 1 upon n under root minus 1 upon n under root of 2x square minus x square bracket square 2x square minus x bracket square into ddx of 2x square minus x and normal, that is a dy by dx is equals to 1 minus 4x upon in root of 1 minus x square in bracket 2x minus 1 bracket square. Next is third is y is equals to sine inverse of 2 raised to x. Therefore differentiate this with respect to x. What is the derivative of? इस सर्व प्रॉब्लम सॉल्व करता करता आपकी सर्व सूत्र पाठ असतं. dy by dx is equals to 1 upon in root of 1 minus 2 raised to x bracket square into ddx of 2 raised to x. What is the derivative of 2 raised to x? 2 raised to x into log of 2. Therefore, that is a 2 raised to x log of 2. And this can be again written as 2 raised to 2x means or 2 raised to 2 whole bracket raised to x. That is 1 minus 4 raised to x. Therefore, dy by dx is equals to 2 raised to x into log of 2 upon in root of 1 minus 4 raised to x. Now the fourth one, y is equals to cot inverse of 1 upon x square, and that is equals to tan inverse of x square. Therefore, now differentiate this with respect to x. That is the dy by dx is equals to 1 upon in root of 1 upon, it is not root, 1 upon 1 plus x square bracket square into ddx of x square. Because it is, there is not x, if there is other than x, then differentiate it, multiply. That is 1 upon x raised to 4 into derivative of x square is a 2x. Therefore, dy by dx is equals to 2x upon 1 plus x raised to 4. Y is equals to cot inverse of 1 upon x square. That is a y is equals to cos inverse in root of 1 plus x upon 2. Now again differentiate this with respect to x. That is a dy by dx is equals to minus 1 upon in root of 1 minus in root of 1 plus x upon 2 bracket square into ddx of a root of 1 plus x upon 2 that is minus 1 upon 1 plus x upon 2 into the derivative, that is 1 upon 2 times in root of 1 plus x upon 2 into ddx of 1 plus x upon 2, that is a simplification, that is a 2 minus 1 minus x upon 2 into root, that is there is a root because here is a 2 and this is a root 2. 2 upon root 2, that is a root 2 in root of 1 plus x into 1 upon 2. That is a minus root 2 upon in root of 1 minus x into root 2 in root of 1 plus x 1 upon 2. Therefore, dy by dx is equals to 1 upon 2 in root of 1 minus x square. That is the root of 1 minus x and root of 1 minus x. And that is the root of 1 minus x square Therefore, dy by dx is equals to minus 1 upon 2 in root of 1 minus x square. Sixth one, y is equals to sine square in bracket sine inverse of x square a very interesting example. This is a sine of sine inverse of x square. Sine of sine inverse of theta, that is a theta, means what? X square, bracket square. And now differentiate this with respect to x. Therefore, dy by dx is equals to 4x cubed. Differentiate the following with respect to x. Y is equals to cos inverse 4 cos cube x minus 3 cos x. That is the cos inverse of cos inverse of cos of 3x, that is nothing but the formula, and cos inverse of cos of 3x is y is equals to 3x. Differentiate with respect to x, and derivative of dy by dx is equals to 3. Y is equals to cos inverse sine of 4 raised to x. And now this can be solved using, that is the cos inverse of sine of 4 raised to x can be written as y is equals to cos inverse, that is a cos of pi by 2 minus 4 raised to x, and that is nothing but pi by 2 minus 4 raised to x. Therefore, dy by dx is equals to 0. Derivative of pi by 2 is 0, and derivative of 4 raised to x is a 4 raised to x into log of 4. Next is now third is y is equals to sine inverse in root of 1 minus cos of x upon 2. That is 1 minus cos of x 2 sine square x upon 2 upon 2. These two get cancelled. Sine inverse of square and root sine get cancelled. That is a sine inverse of sine of x by 2. That is equals to x by 2. Therefore, differentiate this with respect to x. Therefore, dy by dx is equals to 1 upon 2. Next is y is equals to tan inverse 1 minus cos of 3x upon sine of 3x. That's a tan inverse. That is a 2 sine square 3x upon 2. And sine of 3x means what? 2 sine of 3x upon 2 into cos of 3x upon 2. Now here 1 sine of 3x upon 2, 1 sine of 3x upon 2 get cancelled. That is a tan inverse of sine of 3x upon 2 cos of 3x upon 2 That is the tan inverse of tan of 3x upon 2. That is nothing but the 3x upon 2. And it's very simple derivative. Derivative of x is 1. And therefore 1 into 3 by 2. Therefore dy by dx is equals to 3 by 2. Now fifth one. Y is equals to cot inverse of cos x upon 1 plus sin x. Now this can be converted into tan. That is the cot inverse of x is equals to tan inverse of 1 upon x. And therefore tan inverse of 1 plus sin x upon cos x. Now this must be tan x. Then how it is? Now this 1 means what? Cos square x by 2. This is very standard and most useful formula. That is a cos of x by 2 plus sin of x by 2 bracket square. 1 plus sin x means what? That we have also used this formula before this. And cos x means what? Cos of 2 times theta means what? That is a cos of 2 times theta means what? Cos square theta minus sin square theta. But now here is a cos x. Means what? Cos square x by 2 minus sin square x by 2. Again here is a 1 means what? That is a cos square x by 2 plus sin square x by 2. And sin x means what? 2 sin x by 2 into cos x by 2. And that is a cos of x by 2 plus sin of x by 2 bracket square upon cos square x by 2 minus sin square x by 2. And that's why one term will be get cancelled. Then you will get tan inverse of, this is the formula. That is 1 plus sin x cos square x by 2 plus sin square x by 2 plus 2 sin x by 2 into cos x by 2. And this is nothing but tan inverse of cos of x by 2 plus sin of x by 2 upon cos of x by 2 minus sin of x by 2 and split up it. That is, here is a, now see this, that is a cos of x by 2 plus sin of x by 2 bracket square. That it is multiplied 2 times. Now what is here? A square minus b square. Then in first bracket a minus b, in second bracket a plus b. Now plus term will get cancelled. Again, there is one more thing is that which is commonly used in the 12th standard of this type of the mathematics. That is, we divide numerator and the denominator, which is the cos of x by 2. If we divide the cos of x by 2 plus sin of x by 2 by cos of x by 2 to the numerator, then cos of x by 2 upon x by 2 is 1 plus sin of x by 2 upon cos of x by 2 is a tan of x by 2. Here is again 1, here is a minus tan of x by 2. That's a 1 plus tan of x by 2 upon 1 minus tan of x by 2. That's a tan inverse of dividing by numerator and the denominator that is a tan inverse of tan of pi by 4 plus x by 2. Now tan inverse of tan of pi by 4 x by 2. Therefore differentiate this with respect to x. That is a dy by dx is equals to derivative of pi by 4 is 0 and x upon 2. The derivative of x is 1. That is 1 upon 2. Now next is differentiate the following. With respect to x, y is equals to sin inverse in bracket 2 cos x plus 3 sin x upon root of 13. That is a sin inverse 2 upon root of 13 cos x plus 3 upon root of 13 sin x. Therefore you will get, that is a 2 upon root 13 that is a, b, c that is a 2 upon root of 13. That is, here must be the sign. How it can get? Therefore, we take here alpha, that is opposite side upon hypotenuse. That is a 2 upon root 13. This is the sine of alpha. And what about the cos of alpha? Adjacent side upon hypotenuse. That is a 3 upon root of 13. Therefore, y is equals to sine inverse in bracket sine of alpha into cos x plus cos of alpha into sin x. And therefore, y is equals to sine inverse in bracket sine of x plus alpha. And therefore, y is equals to sine inverse of sine of x plus alpha, and that is nothing but the y is equals to x plus alpha. Now differentiate this with respect to x. Dy by dx is equals to 1 plus 0. Therefore, dy by dx is equals to 1. Second, y is equals to cos inverse in bracket 3 sin x square plus 4 cos x square upon 5. Again, same type of the problems are here. We draw the triangle, take alpha angle. Now in the outside bracket there is a cos, therefore we must get here also cos. That is a 3 by 5, 4 by 5. Therefore we take the triangle alpha ABC. That is the sine of alpha is equals to 3 by 5 and cos of alpha is equals to 4 by 5. Therefore, y is equals to cos inverse sine of alpha sine of x square plus cos of alpha into cos of x square. That is, y is equals to cos inverse in bracket cos of x square minus alpha. That is the cos inverse of cos of x square minus alpha. That is, y is equals to x square minus alpha. Now differentiate this with respect to x. Then derivative of x square is a 2x and derivative of alpha is 0. Therefore, dy by dx is equals to 2x. Third, y is equals to sine inverse a cos x minus b sin x upon in root of x square plus b square. That is a sine inverse a upon in root of a square plus b square cos x minus b upon in root of a square plus b square sin x. I forget to write that is a sin x. Again, there is a triangle and the sides of the triangles are a and b, alpha angle, and the hypotenuse is in root of a square plus b square. Therefore, y is equals to sine inverse. That is sine alpha into cos x minus cos alpha into sin x. This is I forget to write. Now in the outside bracket there is a sign, therefore in bracket there must be sign. And this is nothing but the expansion of sine of alpha minus x. Therefore y is equals to alpha minus x. Differentiate this with respect to x. Therefore dy by dx is equals to dy by dx is equals to minus 1. Next, differentiate 1 y is equals to sine inverse in bracket 2x upon 1 plus x square. Now here substitutions. Put x is equals to tan theta. There is one more thing is that is a tan of 2 times theta is equals to 2 tan theta upon 1 plus tan square. This is the sine of 2 times theta. That is the sine of 2 times theta is a 2 tan theta upon 1 plus tan square theta. And therefore sine inverse of sine of 2 times theta, that is y is equals to 2 theta. And what is a theta? Theta is a tan inverse of x. Y is equals to 2 tan inverse of x. Differentiate with respect to x. Therefore dy by dx is equals to 2 upon 1 plus x square. Second, y is equals to cos inverse in bracket 2x upon in root of 1 minus x square. Put x is equals to sine theta. Theta is equals to sine inverse of x. That's a cos inverse in bracket 2 sine theta in root of 1 minus sine square theta. That is y is equals to cos inverse. That is a 2 sine theta into cos theta. That is a cos inverse of sine of 2 times theta. That is a cos inverse of cos of pi by 2 minus 2 theta. That is a pi by 2 minus 2 times theta. But what is a theta? Theta is a sine inverse of x. Now differentiate this with respect to x. dy by dx is equals to derivative of pi by 2 is 0 minus 2. Derivative of sine inverse of x is 1 upon in under root of 1 minus x square. Therefore dy by dx is equals to minus 2 upon in under root of 1 minus x square. Y is equals to cosec inverse of 1 upon 3x minus 4x cube. Now this can be converted into the sine inverse. That is the cosec inverse of 1 upon x is sine inverse of 3x minus 4x cube. Now again put x is equals to sine theta. Theta is equals to sine inverse of x. Y is equals to sine inverse 3 sine theta minus 4 sine cube theta. And therefore y is equals to sine inverse sine of 3 theta, and that is equals to 3 theta. But what is the theta? Theta is a sine inverse of x. Therefore, now differentiate this with respect to x. Dy by dx is equals to 3 upon in root of 1 minus x square dy by dx is equals to 3 upon in root of 1 minus x square. This is the fourth one. Y is equals to tan inverse 2 e raised to x upon 1 minus e raised to 2x. Now here is e raised to x is equals to tan theta, and therefore theta is equals to tan inverse of e raised to x. Therefore y is equals to tan inverse of 2 tan theta upon 1 minus tan square theta. Therefore y is equals to tan inverse of tan of 2 times theta. This is nothing but the formula for the tan of 2 times theta. Therefore y is equals to 2 theta, and if we substitute, that is y is equals to 2 tan inverse of e raised to x. And what is it's a differentiation. Therefore dy by dx is equals to 2 upon 1 plus e raised to x bracket square into derivative of e raised to x. And derivative of e raised to x is e raised to x. Therefore dy by dx is equals to 2 e raised to x upon 1 plus e raised to x. Therefore dy by dx is equals to 2 e raised to x upon 1 plus e raised to 2x. Next is y is equals to cos inverse in bracket 1 minus 9x square upon 1 plus 9x square and it can be written as like this. That is a 3x is equals to tan theta and theta is equals to tan inverse of 3x. Therefore, y is equals to cos inverse in bracket 1 minus tan square x upon tan square theta upon 1 plus tan square theta. And that is nothing but the cos inverse of cos of 2 times theta. That is equals to 2 theta. But what is the theta? Theta is equals to tan inverse of 3x. Now differentiate this with respect to x. That is the dy by dx is equals to 2 upon 1 plus 3x bracket square into ddx of 3x, which is 3. That is 3 into 2, 6. That is 1 plus 9x square. Therefore, dy by dx is equals to 6 upon 1 plus 9x square. Now the sixth one, y is equals to cos inverse in bracket 2 raised to x minus 2 raised to minus x upon 2 raised to x plus 2 raised to minus x. This is also very interesting. To solve this, that is a 2 raised to x minus 2 raised to x upon divide n and d by 2 raised to x. Therefore, you will get cos inverse 1 minus 2 raised to minus x bracket square upon 1 plus 2 raised to minus x bracket square. Put 2 raised to minus x is equals to tan theta, and therefore theta is equals to tan inverse of 2 raised to minus x. Y is equals to cos inverse 1 minus tan square theta upon 1 plus tan square theta. Therefore, y is equals to cos inverse of cos of 2 times theta. This is very important formula in trigonometry. That is 1 minus tan square theta upon 1 plus tan square theta is a cos of 2 times theta. मॅथमॅटिक्स मध्ये जेवढे तुम्ही प्रॉब्लेमचा सराव करणार तेवढे तुम्हाला सर्व फॉर्म्युलीज लगेच लक्षात येत राहतील. अदरवाइज जर तुम्ही 1 महिन्यानंतर 2 महिन्यानंतर जर पुन्हा बघितलं तर तुम्हाला पुन्हा पहिल्यापासून लक्षात ठेवावं लागणार आहे. म्हणून रोज नियमित तुम्ही every day you have to solve the 20 examples from M1 and M2. That is the y is equals to 2 times tan inverse of 2 raised to minus x. Now differentiate this with respect to x. Therefore, dy by dx is equals to 2 upon 1 plus 2 raised to minus x bracket square into ddx of 2 raised to minus x. Therefore, dy by dx is equals to 2 upon 1 plus 2 raised to minus 2x into derivative of 2 raised to minus x is log 2 raised to minus x log of 2 into derivative of minus x is minus 1. That is a minus 2 into 2 raised to minus x log of 2 upon 1 plus 2 raised to minus 2x. Now evaluate this. That is a minus 2 into 2 raised to, or it can be written as 2 raised to, here the index is 1. That is 1 minus x log of 2 upon 1 plus 1 upon 2 raised to 2x. And if you evaluate this, then you will get 2 raised to 2x plus 1 upon 2 raised to x, and multiplied and reciprocal, then you will get, that is a 2 raised to 2x to the numerator. And if you evaluate this, then you will get minus 1 minus x and plus 2x. If we evaluate this, plus 2x and minus x, there will be the x, that is the 2 raised to x plus 1 into log of 2 upon 1 plus 2 raised to 2 bracket raised to x. Therefore, dy by dx is equals to minus 2 raised to x plus 1 log of 2 upon 1 plus 2 raised to 2x. Now the next example, 7th. Y is equals to tan inverse in root of 3 minus x upon 3 plus x. I had taken all the short examples because these examples asked in the CET and also board exam. Therefore, x is equals to, now substitution. This is very typical substitutions, I always say. This is a minus x and a plus x. Therefore, x is equals to 3 cos of 2 times theta. X upon 3 is equals to cos of 2 times theta. Therefore, 2 theta is equals to cos inverse of x upon 3. Therefore, theta is equals to 1 upon 2 cos inverse of x upon 3. That is y is equals to tan inverse in root of 3 minus 3 cos of 2 times theta upon 3 plus 3 cos of 2 times theta. Take 3 as a common, then 3 will get cancelled. In bracket you will get 1 minus cos of 2 theta upon 1 plus cos of 2 times theta. Therefore, tan inverse of, in bracket, 1 minus cos of 2 times theta upon 1 plus cos of 2 times theta, bracket complete. And that's why you will get y is equals to tan inverse. That is 1 minus cos of 2 times theta. That is a 2 sin square theta, 2 theta upon 2. That is 2 sin square theta upon 2 cos square theta. That is a square and root sign get cancelled. You will get the tan of theta. Tan inverse of tan of theta, that is a theta. What is a theta? Theta is equals to 1 upon 2 cos inverse of x upon 3. Now differentiate this with respect to x. Therefore, dy by dx is equals to minus 1 upon 2 in root of 1 minus x upon 3 bracket square into ddx of x upon 3. Now what is the derivative of x upon 3 is 1 upon 3. That is 1 upon 2 minus 1 upon 2 into 1 upon 3. 1 upon in root of 9 minus x square upon 9. And that's why there is a minus 1 upon 2 into 1 upon in root of 9 minus x square. And this is the answer. Now the next problem. Here can y is equals to sin inverse 5 in root of 1 minus x square minus 12x upon 30. Now put x is equals to sin theta. All these substitutions you will understand when you do the practice more and more. That is, in square bracket we must have the sin of theta, and that's why x is equals to sin theta. Theta is equals to sin inverse of x, and that is a 5 cos theta minus 12 sin theta upon 13. Now 5 upon 13 must be the sin theta and 12 upon 13 must be the cos theta. Draw the right angle triangle and consider the one more angle, that is this is the alpha ABC. That is the 5, 13, 12. Therefore, sine of alpha is equals to 5 upon 13 and cos of alpha, not theta, I had written as there is a theta, here is alpha, by mistake, 12 upon 13. Therefore, sine inverse of sine of alpha into cos theta minus this alpha, cos alpha into sine theta. Therefore, y is equals to sine inverse of sine of alpha minus theta. That is y is equals to alpha minus theta. That y is equals to alpha minus sine inverse of x. Differentiate this with respect to x. Therefore, dy by dx is equals to minus 1 upon in root of 1 minus x square. Now the 9th example. Y is equals to sine inverse 2 raised to x plus 1 upon 4 raised to x upon 1 plus 4 raised to x. Now these are very interesting substitutions. That is, in bracket you will also have the 2 times tan theta upon 1 plus tan square. That is, y is equals to sine inverse 2 into 2 raised to x. All these solved examples are very important. 1 plus 2 raised to x bracket square. Now put 2 raised to x is equals to tan theta. And therefore, theta is equals to tan inverse of 2 raised to x. Therefore, y is equals to sine inverse in bracket 2 tan theta upon 1 plus tan square theta. Therefore, y is equals to sine inverse. That's a 2 tan theta upon 1 plus tan square theta means what? Sine inverse of sine of 2 times theta. And that is equals to 2 theta. That is a 2 tan inverse of 2 raised to x. Sorry. Sine inverse here, that is theta is equals to, that is a 2 tan inverse of 2 raised to x. Therefore, y is equals to 2 tan inverse of 2 raised to x. Now differentiate this with respect to x. Therefore, dy by dx is equals to tan inverse of 2 raised to x. What is the derivative of tan inverse of x? That is 1 upon 1 plus x square. That is 1 upon 1 plus 2 raised to x bracket square into ddx of 2 raised to x. That is a 2 upon 2 raised to 2x into derivative of 2 raised to x. That is a 2 raised to x into log of 2. And that's why dy by dx is equals to 2 raised to x plus 1 log of 2 upon 1 plus 4 raised to x. Next, question number 6. And this question will conclude all the solid example. Differentiate the following with respect to x. First, tan inverse of 4x upon 1 plus 21x square. Therefore, tan inverse of 4x upon 1 plus 21x square, that is the tan inverse of 7x minus 3x upon 1 plus 7x into 3x, that is equals to y is equals to tan inverse of 7x. Tan inverse of 7x minus tan inverse of 3x. And now differentiate this with respect to x. Differentiate with respect to x, dy by dx is equals to 1 upon 1 plus 7x bracket square, that is 49x square into derivative of 7x, that is 7. Minus 1 upon 9x square into derivative of 3x, that is a 3. Therefore, dy by dx is equals to 7 upon 1 plus 49x square minus 3 upon 1 plus 9x square. Now the next is y is equals to tan inverse of 7x upon 1 minus 12x square, and this can be written as 7x can be written 3x plus 4x upon 1 minus 3x into 4x. Well, y is equals to tan inverse of 3x plus tan inverse of 4x. Now differentiate this with respect to x. Therefore dy by dx is equals to, that is 1 upon 1 plus 9x square into ddx of 3x plus 1 upon 1 plus 16x square into ddx of 4x, that is 4. Therefore dy by dx is equals to 3 upon 1 plus 9x square plus 4 upon 1 plus 16x square. This is the answer. Now the next is third one. Y is equals to cot inverse in bracket b sin x minus a cos x upon a sin x plus b cos x. Now here we will convert it into the tan inverse of a sin x plus b cos x. Sorry, a sin x plus b cos x upon b sin x minus a cos x bracket complete. Now divide numerator and the denominator by b sin x, because here we will require the tan, and for that here b sin x, in this place we will require 1. Therefore divide n and d by b sin x. If we divide b sin x, then tan inverse of a upon b plus cot x 1 minus a upon b cot x, and this is nothing but tan inverse of a upon b plus tan inverse of cot of x. Now convert this cot into the tan, that is it, tan of pi by 2 minus x, and that's why you will get tan inverse of a upon b plus tan inverse of pi by 2 minus x, and therefore differentiate this with respect to x. Therefore dy by dx is equals to 0, derivative of tan inverse of a upon b plus pi by ddx of pi by 2 minus x, and derivative of tan inverse of a by b is 0, tan inverse of pi by 2 is 0, tan inverse of x is minus 1. Therefore dy by dx is equals to minus 1. And the fourth one, I think that this is the last solved example. All the solved examples are very, very important. That's why the length of this video is more and more. But once you do the study from this, then you will have the perfectness. Now y is equals to tan inverse of 5x plus 1 upon 3 minus x minus 6x square. That's the tan inverse of 5x plus 1 upon 1 plus 2. Now these 3 can be written as 1 plus 2 minus x minus 6x square. Now see this here, that is the 1, take minus sign is common, then 6x square plus x minus 2. Now factorize this and then arrange the numerator. Now 6x square plus x minus 2 can be factorized. (3x plus 2) and 2x minus 1. Now factorize by using the and then we can arrange that numerator. That is the tan inverse of 5x plus 1 upon 1 minus is 2x in bracket 3x plus 2 minus 1, 3x plus 2. That is the tan inverse of 5x plus 1 upon 1 minus, in first bracket 3x plus 2, 2x minus 1. That is the tan inverse of 3x plus 2 plus 2x minus 1 upon 1 minus 3x plus 2 into 2x minus 1. And this is nothing but the tan inverse of 3x tan inverse of 3x plus 2 plus tan inverse of 2x minus 1. Now differentiate this with respect to x. That is 1 upon 1 plus in bracket 3x plus 2 bracket square into ddx of 3x plus 2. Therefore, dy by dx is equals to 3 upon 1 plus 3x bracket square plus 2 upon 1 plus 2x minus 1 bracket square. Therefore, dy by dx is equals to 3 upon 1 plus 3x plus 2 bracket square plus 2 upon 1 plus 2x minus 1 bracket square. In this way, all the solving. Now let us start the exercise 1.2. First, find the derivative of the function y is equals to f of x using the derivative of the inverse function x is equals to f inverse of y. First, that is y is equals to root x. Therefore, we find the inverse of the function y is equals to f of x. That is x in terms of y. Therefore, squaring on both sides, you will get x is equals to y square. Therefore, x is equals to y square. X is equals to f inverse of y. Therefore, dy upon dx is equals to dx upon dy. That is a 1 upon 2y. What is the derivative of y square? X is equals to y square. That is a 2y. But what is the y? Y is a root x. Therefore, dy by dx is equals to, what is the y? Y is a root x. Therefore, dy by dx is equals to 1 upon 2 root x. Next is now again see this x is equals to y is equals to root x. Squaring on y is equals to root x. Squaring on both sides, x is equals to y square. And that's why x is equals to f inverse of y is equals to y square. Therefore, dy by dx is equals to 1 upon dx upon dy is equals to 1 upon 2y. But the value of the y is root x. Here is a root x. Substitute. Therefore, you will get therefore dy by dx is equals to 1 upon 2 root x. Now we will see again. Next. Second, y is equals to in root of 2 minus root x. That is y is equals to root of 2 minus root x. Now we first write this. Now here is y is equals to in root of 2 minus root x. First we find the inverse of the function y is equals to f of x. That is a x in terms of y. Therefore, now squaring on both sides, then you will get y square is equals to 2 minus root x. Therefore, y square minus 2 is equals to minus root x. Again squaring on both sides. That is y square minus 2 bracket square is equals to x. Therefore, x is equals to y square minus 2 bracket square. Therefore, x is equals to f inverse of y is equals to y square minus 2 bracket square. Therefore, dy by dx is equals to 1 upon dx upon dy. That is nothing but 1 upon 2 in bracket y square minus 2 into derivative of y square minus 2, that is a 2y. Therefore, dy by dx is equals to 1 upon 4y in bracket y square minus 2. Now express this y in terms of x. That is 1 upon 4 in root of 2 minus root x into minus root x. Therefore, dy by dx is equals to minus 1 upon root x in bracket root of 2 minus root x, that is minus 1 upon 4 root x in bracket root of 2 minus root x. Now the next example is y is equals to cubic root of x minus 2. We first find the inverse of the function y is equals to f of x, that is a x in terms of y. That is y is equals to cubic root of x minus 2. Take cube on both sides. Y cube is equals to x minus 2. X is equals to y cube plus 2. Therefore, x is equals to f inverse of y, that is y cube plus 2. Dx, dy by dx is equals to 1 upon dx upon dy, that is 1 upon 3y square, that is equals to, and now express this y in terms of x, that is a 3 cubic root of x minus 2 bracket square. Therefore, dy by dx is equals to 1 upon 3 x minus 2 bracket raised to 2 upon 3. Therefore, dy by dx is equals to 1 upon 3 into cubic root of x minus 2 bracket square. Now the next example is y is equals to log of 2x minus 1. First find the inverse of the function y is equals to f of x, that is x in terms of y is equals to log of 2x minus 1. Therefore, Now here is a log function, that is e raised to y is equals to 2x minus 1. Therefore, x is equals to e raised to y plus 1 upon 2. Therefore, x is equals to f inverse of y is equals to e raised to y plus 1 upon 2. Therefore, dy by dx is equals to 1 upon dx upon dy. That is 1 upon e raised to y plus e raised to y upon 2. That is 2 upon e raised to y. Therefore, dy by dx is equals to 2 upon e raised to y. Now express this e raised to y in terms of x. That is 2 upon 2x minus 1. Therefore, dy by dx is equals to 2 upon 2x minus 1. Now we'll see the same problem again. Now see this again, which is this is the problem, which is y is equals to log of 2x minus 1. Therefore, y is equals to log of 2x minus 1 e raised to y is equals to 2x minus 1. Therefore, x is equals to e raised to y plus 1 upon 2. X is equals to f inverse of y is equals to e raised to y plus 1 upon 2. Therefore, dy by dx is equals to 1 upon dx upon dy. That is equals to 1 upon e raised to y upon 2. That is 2 upon e raised to y. And that's why dy by dx is equals to 2 upon e raised to y. Therefore, 2 upon the value of the e raised to y. The value of the e raised to y is 2x minus 1. Therefore, resubstitute here, that is 2 upon 2x minus 1. Therefore, dy by dx is equals to 2 upon 2x minus 1. Now the next is fifth one. Y is equals to 2x plus 3. Again, express this y, x in terms of y. Y is equals to f of x, that is x in terms of y. Therefore, y is equals to, that is y minus 3 upon 2 is equals to x, x is equals to y minus 3 upon 2, x is equals to f inverse of y, that is equals to y minus 3 upon 2. Therefore, dy by dx is equals to dx upon dy. What is the derivative of y is 1 upon 2, that is 1 upon 2, that is equals to 2. Therefore, dy by dx is equals to 2. Also, see this again here, that is y is equals to 2x plus 3. We find the inverse of the function y is equals to f of x, that is x in terms of y. Y minus 3 upon x. Y minus 3 upon 2 is equals to x. Therefore, x is equals to y minus 3 upon 2. X is equals to f inverse of y is equals to y minus 3 upon 2. Now differentiate, dy by dx is equals to 1 upon dx upon dy. Derivative of y is 1, derivative of 3 is 0, that is 1 upon 2. Therefore, dy by dx is equals to 1 upon 2, that is nothing but the 2. Therefore, dy by dx is equals to 2. Next is number 6. Y is equals to e raised to x minus 3. Therefore, we first find the inverse of the following. Y is equals to f of x. That is x in terms of y. But y is equals to e raised to x minus 3. Therefore, e raised to x is equals to y plus 3. Therefore, x is equals to log of y plus 3. X is equals to log of y plus 3. Therefore, x is equals to f inverse of y. Therefore, x is equals to log of y plus 3. But Now dy by dx is equals to 1 upon dx upon dy. That is 1 upon derivative of this 1 upon y plus 3. Now dy by dx is equals to y plus 3. What is the value of y? Y is e raised to x minus 3 plus 1. Therefore dy by dx is equals to e raised to x. Now see this again. Y is equals to e raised to x minus, we will first find the inverse of the function. Y is equals to f of x, that is x in terms of y. Y is equals to e raised to x minus 3. Therefore e raised to x is equals to y plus 3. X is equals to, now express, this is the exponential form. Exponential form can be converted into the log form. Therefore the x is equals to log of y plus 3. Now x is in the form of the y. X is equals to f inverse of y. That is equals to log of y plus 3. Therefore dy by dx is equals to 1 upon dx upon dy. Now derivative of this x is equals to log of y plus 3 is a 1 upon y plus 3. And that's why dy by dx is equals to y plus 3. But what is the y? Y is e raised to x minus 3. That is e raised to x minus 3 plus 3. And that's why dy by dx is equals to e raised to x. Now the next is y is equals to e raised to 2x minus 3. Therefore we first find the inverse of the function y is equals to f of x. That is x in term of y. That is y is equals to e raised to 2x minus 3. Therefore log of y is equals to 2x minus 3. Take log on both sides. If we take log of e raised to 2x minus 2 to the base e, that is nothing but the 2x minus 3. Therefore 2x is equals to 3 plus log y. X is equals to 3 plus log of y upon 2. X is equals to f inverse of y. That is x is equals to 3 plus log of y upon 2. Therefore dy by dx is equals to 1 upon dx upon dy. That is 1 upon, this is the derivative of log of y, is a 1 upon y. That is a derivative of 3 is 0. That is a 1 upon 2y. That is a dy by dx is equals to 2 into e raised to 2x minus 1. I will show now again. Now see this here. Y is equals to e raised to 2x minus 3. First find the inverse of the function y is equals to f of x. That is x in terms of y. Y is equals to e raised to 2x minus 3. Log of y is equals to 2x minus 3. Take log on both sides. And therefore log of e raised to 2x minus 3 to the base e, that is nothing but the 2x minus 3 is equals to log y. And therefore 2x is equals to 3 plus log of y. Therefore x is equals to 3 plus log of y upon 2. Therefore x is equals to f inverse of y. That is 3 plus log of y upon 2. Therefore dy by dx is equals to 1 upon dx upon dy. Now what is the derivative of log of y? Is 1 upon y. Derivative of 3 is 0. That is 1 upon 2y. Now if we simplify, then you will get 2y upon 1. That is the dy by dx is equals to 2y. And hence substitute the value of the y. But what is the value of y? Y is e raised to 2x minus 3. Resubstitute the value of y. That is the dy by dx is equals to 2 into e raised to 2x minus 3. It's a very simple thing that if we find out the derivative of this, then what is the dy by dx? Dy by dx is equals to e raised to 2x minus 3 into derivative of 2x minus 3, which is a 2. There is a 2 into e raised to 2x minus 3. And this is we find by using the definition of the inverse function. Next is a problem number 8. y is equals to log of x upon 2 to the base 2. We first find the inverse of the function y is equals to f of x, that is x in term of y is equals to log of x upon 2 to the base 2. Therefore, x upon 2 is equals to this logarithmic can be converted into exponential, that is a 2 raised to y. Therefore, x is equals to 2 into 2 raised to y. Therefore, x is equals to 2 raised to y plus 1. X is equals to f inverse of y. Therefore, x is equals to 2 raised to y plus 1. Therefore, dy by dx is equals to 1 upon dx upon dy. That is 1 upon 2 raised to y plus 1 into log of 2. Therefore, dy by dx is equals to 1 upon 2 raised to y plus 1 into log of 2. And therefore, dy by dx is equals to, substitute the value of the y. That is the dy by dx is equals to 1 upon x into log of 2. Now, see this again here. That is y is equals to log of x upon 2 to the base 2. Therefore, 2 raised to y is equals to x upon 2. Therefore, x is equals to 2 into 2 raised to y. Therefore, x is equals to 2 raised to y plus 1. X is equals to f inverse of y. That is equals to 2 raised to y plus 1. Therefore, dy by dx is equals to 1 upon dx upon dy. That is equals to 1 upon. What is the derivative of 2 raised to y plus 1? The derivative of 2 raised to y plus 1 is 2 raised to y plus 1 into log of 2. Therefore, dy by dx is equals to 1 upon 2 raised to y plus 1 into log of 2. And that's why, what is the value of the y? That is the y is equals to log of x upon 2 to the base 2. That is, we substitute the value. Therefore, dy by dx is equals to 1 upon, this is the x and log of 2. That is the x is equals to 2 raised to y plus 1. We substitute here 2 raised to y plus 1 is x. Now the next is question number 2. Find the derivative of inverse function of the following. First is y is equals to x square into a raised to x. Now differentiate this with respect to x. Therefore, we get dy by dx is equals to 2x into e raised to x plus x square into e raised to x. That is dx of, apply the product rule. Therefore, x square is into e raised to x plus e raised to x. Derivative of x square is a 2x. Take e raised to x as a common. X into e raised to x as common. Then you will get x into e raised to x in bracket x plus 2. Now the next is, we have dx upon dy is equals to 1 upon dy by dx. Therefore, x into e raised to x upon 1 upon x into e raised to x into in bracket x plus 2. Therefore, dx upon dy is equals to 1 upon x into e raised to x into x plus 2. This is the answer. In the same way, that is, you can see this again. Normal product rule is there. Find out its a derivative, and you will get the answer of that question. That is a dx upon dy is equals to 1 upon x into e raised to x in bracket x plus 2. And the derivative of the inverse of the function. That's a dx upon dy. This is the inverse function. Now, next is y is equals to x cos of x. Now differentiate this with respect to x. That is x into ddx of cos of x plus cos of x into ddx of x. Derivative of cos x is minus sin x, and derivative of x is 1. Therefore, minus x into sin x plus cos x. Therefore, dy by dx is equals to minus x sin x plus cos x. And therefore, dx upon dy is equals to 1 upon dy by dx. And that is equals to 1 upon minus x sin x plus cos x. And this is the answer. Normal things are here. Again, you want to see this here. Y is equals to. Find out their derivatives by using the product rule. Therefore, dy by dx is equals to minus x sin x plus cos x. Therefore, dx upon dy is equals to 1 upon dy by dx. That is equals to 1 upon minus x sin x plus cos x. And that's why dx upon dy is equals to 1 upon cos x minus x sin x. Now the next is third, y is equals to x into 7 raised to x. Now differentiate this with respect to y is in the product rule. Therefore, derivative of 7 raised to x is 7 raised to x into log of 7, and derivative of x is 1. Normal derivative is there. X into 7 raised to x into log of 7 plus 7 raised to x. Derivative of x is 1. dy by dx is equals to dx upon dy is equals to 1 upon dy by dx. We can take 7 raised to x common. Therefore, dx upon dy is equals to 7 raised to x in bracket x log of 7 plus 1. Therefore, dx upon dy is equals to 1 upon 7 raised to x in bracket x log of 7 plus 1. Again, you can see this here. That is y is equals to x into 7 raised to x by product rule. Derivative are very easy. 7 raised to x into log of 7. Derivative of x is 1. Dx upon dy is equals to 1 upon dy by dx. 1 upon x into 7 raised to x into log of 7 plus 7 raised to x. Take 7 raised to x as a common, and you will get the answer. Next is y is equals to x square plus log x. Very simple question. That is the derivative of x square is 2x, log of x is 1 upon x. Therefore, dx upon dy is equals to, that is dx upon dy is equals to 1 upon 2x plus 1 upon 2x plus 1 upon x, and simplify it. Then you will get the answer. That is a 2x square plus 1 upon x. That is a dx upon dy is equals to x upon 2x plus 1. Therefore, If you want to see the answer of the fourth question, this is the answer. Okay. Next is fifth one, y is equals to x log x. By applying the product rule, dy by dx is equals to x log x, x into ddx of log x plus log x into derivative of x. Therefore, x into log of x, derivative of log of x is 1 upon x plus log of x, derivative of ddx of by mistake is written. Therefore, dx upon dy is equals to 1 upon dy by dx. That is 1 upon 1 plus log x. Therefore, dx upon dy is equals to 1 upon 1 plus log x. Now see this here. By mistake here must be x. That is I had written the next step. Therefore, dy by dx is equals to 1 plus log x. Therefore, dx upon dy is equals to 1 upon 1 plus the next. Now the question number 3. Find the derivative of the inverse of the following functions. And also find their values at the point indicated against them. Y is equals to x raised to 5 plus 2x cubed plus 3x at x is equals to 1. Now differentiate this with respect to x. Dy by dx is equals to 5x raised to 4 plus 6x square plus 3. Therefore, dx upon dy is equals to dy by dx. At x is equals to 1. Substitute x, value of the x is 1. That is 1 upon 5 plus 6 plus 3. That is 1 upon 14. This is a simple answer. Now see this answer again. Differentiate this. Find out, is very simple problem. Find out derivatives. Dy by dx. Put x is equals to 1 and hence dy by dx. Dx upon dy at x is equals to 1 is equals to 1 upon 14. Now the next is number 2. Y is equals to e raised to x plus 3x plus 2 at x is equals to 0. Differentiate with respect to x. Therefore, dy by dx is equals to e raised to x plus 3, 0. Dy by dx is equals to e raised to x. E raised to x plus 3. Therefore, dx upon dy is equals to 1 upon dy by dx. And that is 1 upon e raised to x plus 3. At x is equals to 0, replace x by 0, that is 1 plus 3, that is equals to 4. Dx upon dy is equals to 1 upon 1 plus 3, that is 1 by 4. See this again. At x is equals to 0, dy by dx is equals to e raised to x plus 3. Therefore, dx upon dy is equals to 1 upon dy by dx is equals to 1 upon e raised to x plus 3. When x is equals to 0, the 1 upon e raised to 0 plus 3. 1 plus 3, that is 4 dx upon dy is at x is equals to 0 is 1 by 4. Now the next is y is equals to 3x square plus 2 log of x raised to 3 at x is equals to 1. Differentiate this with respect to x. Dy by dx is equals to 6x plus, that is 1 upon x cube into derivative of x cube is a 3x square. That is a 6x plus 6 upon x. Therefore, dx upon dy is equals to 1 upon dy by dx, that is 1 upon 6x plus 6 upon x. Simplify it, then you will get 6x square plus 6, that is x upon 6x square plus 6. Therefore, dx upon dy at x is equals to 1, that is 1 upon 6 plus 6, that is dx upon dy is equals to 1 upon 12. And the next is y is equals to 3x square plus 2 log of x cube. It's a derivative dy by dx 6x plus 2, 1 upon x cube, 3x square. That is the dy by dx is equals to 6x plus 6 upon x. Therefore, dx upon dy is equals to 1 upon dy by dx is equals to 1 upon 6x plus 6 upon x. And substitute the value x is equals to 1, that is 1 upon 6 plus 6. That is 1 upon 12, and hence the answer. Now, you can see this. Next is y is equals to sine of x minus 2 plus x square at x is equals to 2. Now differentiate this again with respect to x. Dy by dx is equals to the derivative of sine is cos and derivative of x square is a 2x. Therefore, dx upon dy is equals to 1 upon dy by dx. That is cos of x minus 2 plus 2x, and at x is equals to 2. That is the cos of 0 plus 2 into 2, that is a 4. Cos of 0 is a 1. 1 plus 4, that is a 5. Dy by dx. Dx upon dy. Now again see this. Y is equals to sine of x minus 2 plus x square at x is equals to 2. Differentiate this with respect to x. Dy by dx is equals to cos of x minus 2 into ddx of x minus 2, that is 1, and derivative of x square is a 2x. That is the dy by dx is equals to cos of x minus 2 plus 2x. Therefore, dx upon dy is equals to 1 upon dy by dx. That is the dx upon dy is equals to 1 upon cos of x minus 2 plus 2x. And at x is equals to 2, 1 upon cos of 2 minus 2, that is a cos 0. cos 0 is 1. 1 plus 4, that is a 5. Therefore, dx upon dy at x is equals to 2 is 1 upon 5. Next is fourth one. If f of x is equals to x raised to 3 plus x minus 2, find f inverse. Find f dash of f inverse of 0. Now first, f of x is equals to x cube plus x minus 2. It's a derivative. That is a 3x square plus derivative of x is 1. That is f dash of x is equals to 3x square plus f dash of, that is a derivative of f inverse of f inverse is equals to 1 upon f dash of x. That is a f dash of f inverse is equals to 1 upon 3x plus 1 at x is equals to 0. That is a derivative of f inverse at x is equals to 0 is 1. Now see this again, I will show you. It was very fast. See this. That is, if f of x is equals to x cube plus x minus 2, find f dash of f inverse at x is equals to 0. The function, it's a derivative. What about its inverse derivative? That is f dash of f inverse is equals to 1 upon f dash of x. But what is f dash of x? 3x square plus 1. At x is equals to 0. That is a f dash of f inverse at x is equals to 0 is 1 upon 3 into 0 plus 1. That is a f dash of f inverse at x is equals to 0 is 1. And hence the answer. Now the next is fifth one. Using the derivative, prove that tan inverse of x plus cot inverse of x is equals to pi by 2. Now again, the same case, that is a cos inverse of x plus sin inverse of x is equals to also pi by 2, that we have proved in the short example. Now we relate f of x is equals to tan inverse of x plus cot inverse of x. That is the one. We have to prove that now differentiate this with respect to x. That is ddx of f of x is equals to ddx of tan inverse of x plus cot inverse of x. That is 1 upon 1 plus x square minus 1 upon 1 plus x square. That is a 0. Therefore, f dash of x is equals to 0. That implies that as it's a derivative 0, the function is constant. And what will be the constant value? Now see this again here. Let f of x is equals to c. For any value of x, f of x must be c, that is for bc only. So conveniently we can choose x is equals to 0. From 1 we get, that is f of 0 is equals to tan inverse of 0 plus cot inverse of 0. That is the tan inverse of 0 is 0 and cot inverse of 0 is pi by 2. Now see this again, tan inverse of 0. That is pi by 2. Tan inverse of 0 is a 0 and the cot inverse of 0, that is a pi by 2. And that's why it implies that c is equals to pi by 2. Therefore, tan inverse of x plus cot inverse of x is equals to pi by 2. And hence, it is a proof. Now, see this again. F of x is equals to pi by 2. We have to prove that this f of x is equals to pi by 2. Its derivative is 0. F dash of x is equals to 0. F of x is a constant function. Let f of x is equals to c. For any value of x, f of x must be c only. So, conveniently, we choose x is equals to 0. That is, f of 0 is equals to tan inverse of 0 plus cot inverse of 0. Tan inverse of 0 is 0 and cot inverse of 0 is a pi by 2. It implies that this is nothing but pi by 2. That is, c is equals to pi by 2. Therefore, this is the answer. Now, next is sec inverse of x plus cosec inverse of x is equals to pi by 2. For mod of x is greater than or equal to 1, let f of x is equals to sec inverse of x plus cosec inverse of x. This is first. We have to prove that f of x is equals to pi by 2. Now differentiate this with respect to x. ddx of f of x is equals to sec inverse of x plus cosec inverse of x, and that is equals to x into 1 upon x into in root of x square minus 1 minus 1 upon x into in root of x square minus 1, and that's achieved. Again, f dash of x is equals to 0. As f dash of x is equals to 0, that is, f of x is equals to is a constant. Now, what about this constant? Is a constant function. Let f of x is equals to c for any value of x, f of x must be c, which is the constant. So conveniently, we can choose that is sec inverse of 1, that is a 1, x is equals to 1, sec inverse of 1 is 0, and cosec inverse of 1 is pi by 2, and that's why c is equals to pi by 2. Therefore, f of x is equals to pi by 2, and hence it is a proof. Now see this again. We have to put that f of x is equals to pi by 2 ddx of f of x is equals to ddx of sec inverse of x plus cosec inverse of x. Their derivatives plus minus f dash of x is equals to 0. The same dialogue is here. F dash of x is equals to 0 implies that f of x is a constant function. Let f of x is equals to c. For any value of x, f of x must be c. So conveniently we choose x is equals to 1. If we put x is equals to 1, then sec inverse of 1 is 0. And the cosec inverse of 1 is a pi by 2, the values. And therefore c is equals to pi by 2. Therefore f of x is equals to pi by 2. Therefore sec inverse of x plus cosec inverse of x is equals to pi by 2. Now perhaps I will break here my video, and next questions, that is these are the questions in the second part of this exercise. Now we'll start the exercise 1.2. That is a question number 6. Differentiate the following with respect to x. Tan inverse of log x so dy by dx is equals to 1 upon derivative of tan inverse of x is 1 upon 1 plus x square, that is 1 upon log of x bracket square into ddx of log x, which is 1 upon x therefore 1 upon x into in bracket 1 plus log of x bracket square. Therefore dy by dx is equals to 1 upon x in bracket 1 plus log of x bracket square. So you can see once again dy by dx is equals to, very simple question. After doing the number of these examples, it's very easy. Next is number 2, that is y is equals to cosec inverse of e raised to minus x. Therefore differentiate with respect to x. The derivative of cosec inverse of x is a minus 1 upon x in root of x square minus 1. Therefore dy by dx is equals to minus 1 upon x, that is e raised to minus x in root of e raised to minus x bracket square into ddx of e raised to minus x. The derivative of e raised to minus x is the e raised to minus x into ddx of again minus x, that is a minus 1. That's why this minus minus will become plus, and this is a simplification, that is a 1 upon in root of 1 upon e raised to 2x minus 1, and if you simplify this then you will get e raised to x upon in root of 1 minus e raised to 2x. This is the dy by dx. Therefore dy by dx is equals to e raised to x upon in root of 1 minus e raised to 2x. See this, how it is a solved. That is dy by dx. Substitute the values, simplification. This is now. Next is third one, y is equals to cot inverse of x cube basic. The derivative of cot inverse of x is a minus 1 upon 1 plus x square. Now here is x cube, that is a minus 1 upon 1 plus x cube bracket square into ddx of x cube, which is a 3x square. That is a dy by dx is equals to minus 3x square upon 1 plus x raised to 6. And that's why that is a dy by dx is equals to minus 3x square upon 1 plus x raised to 6. Now see this again here. It's a normal question. So the answer. Now next is fourth one. That is y is equals to cot inverse of 4 raised to x. Now differentiate this with respect to x. Derivative of cot inverse of x is again minus 1 upon 1 plus 4 raised to x bracket square into ddx of 4 raised to x. That is a log of 4 into log 4 raised to x into log of 4. Therefore minus 1 upon 1 plus 4 raised to 2x into 4 raised to x, derivative 4 raised to x into log of 4. That is a minus 4 raised to x into log of 4 upon 1 plus 4 raised to 2x. Okay. It's very simple. See this here. Next. That is the fifth one. That's the tan inverse of root x. Again, so the dy by dx is equals to 1 upon 1 plus root of x bracket square into ddx of root x. That is a dy by dx is equals to 1 upon 1 plus x, and derivative of root x is 1 upon 2 root x. Therefore dy by dx is equals to 1 upon 2 root x in bracket 1 plus x, and hence it's a derivative. Now see this here. Y is equals to tan inverse of root x. It's a simple derivative. Dy by dx is equals to 1 upon 1 plus root x bracket square ddx of root x. That is 1 upon 2 root x, and that's why dy by dx is equals to 1 upon 2 root x in bracket 1 plus x. Now the next is sixth one. Y is equals to sine inverse in root of 1 plus x square upon 2. Now differentiate this with respect to x. That is 1 upon in root of 1 minus root of 1 plus x square upon 2 bracket square into ddx of 1 plus in root of 1 plus x square upon 2. Therefore dy by dx is equals to 1 upon 1 minus 1 plus x square upon 2 into derivative of root of 1 plus x square upon 2. That is 1 upon 2 times in root of 1 plus x square upon 2 into ddx of 1 plus x square upon 2. And that's why if we simplify this, then you will get that is a 2 minus 1 minus x square upon 2 into that is a 2, that is root 2 upon 2 root of 1 plus x square, and derivative of 1 plus x square upon 2 is a x. And again if we simplify, then you will get 1 minus x square upon 2, that is root 2 upon 1 minus x square. This is normal simplification. Therefore dy by dx is equals to x upon in root of 1 minus x raised to 4. Again see this here. Now the differentiation of this is important. That is 1 upon in root of 1 minus root of 1 plus x square bracket square into ddx of root of 1 plus x square upon 2. That is a dy by dx is equals to 1 upon in root of 1 minus 1 plus x square upon 2 into ddx of 1 upon 2 in root of 1 plus x square upon 2. Now here is again the derivative of 1 plus x square upon 2. That is the derivative of x square is a 2x upon 2, and these two get cancelled. Overall you will get this. That is 1 upon in root of 2 minus 1 minus x square upon 2 into root 2 upon 2 in root of 1 plus x square into x. And again, if we simplify that, you will get this is a root 2 to the numerator upon 1 minus x square into root 2 upon 2 in root of 1 plus x square into x. And overall, if we simplify this, that is the root 2 into root 2 get cancelled. Therefore, x upon in root of 1 minus x raised to 4. And this is the dy by dx. Now the next is seventh. That is y is equals to cos inverse in bracket 1 minus x square therefore its a derivative is a minus 1 upon in root of 1 minus x square bracket square into dx of 1 minus x square. There is a minus 1 upon in root of 1 minus and expansion of this 1 minus 2x square plus x raised to 4 into dx of 1 is 0, x square is a minus 2x, that is a, and again if we simplify this, then you will get that is a minus 2x upon in root of 1 minus in bracket 1 minus x square bracket square. Therefore dy by dx is equals to 2x upon in root of 1 minus in bracket 1 minus x square bracket square. Again, see this here, the seventh one. This is the now the next is this is a correction in the answer. This is my answer. Okay, it's a different from the textbook. Next is eighth, y is equals to sine inverse in bracket x raised to 3 by 2. Therefore dy by dx is equals to 1 upon in root of 1 minus 3 by 2 bracket square into dx of x raised to 3 by 2. That is the dy by dx is equals to 1 upon 1 minus x cube into derivative of x raised to 3 by 2 is 3 by 2 into x raised to 1 upon 2. Therefore dy by dx is equals to root x upon three root x upon 2 in root of 1 minus x cube. Therefore this is a dy by dx. This is again here. Now next is ninth question. Y is equals to cos cube in bracket cos inverse of x cube. That is a cos of cos inverse of x cube and bracket cube. That is x cube and bracket raised to 3. Therefore dy by dx is equals to very simple x raised to 9. Therefore its the differentiation is a 9x raised to 8. Very simple. Therefore dy by dx is equals to 9x raised to 8. See this again here. This is the important cube, total cube, bracket cube. Cos inverse of cos inverse of x cube is nothing but the x cube and bracket cube. That is x is equal to x raised to 9. Therefore, differentiate this with respect to x. There is a 9 into x raised to 8. Therefore, dy by dx is equal to 9 into 8 raised to x. Therefore, next is this is the 10th one. Sin raised to 4 in bracket sin inverse of root of x. It is very simple. That is sin inverse of root x and bracket raised to 4. That is nothing but the x square. That is y is equals to root x raised to 4. Y is equals to x raised to 1 upon 2 bracket raised to 4. That is x square. Therefore, dy by dx is equals to 2x. Dy by dx is equals to 2x. Okay, see this here. Raised to 4. Sin inverse of root x. That is root x bracket raised to 4. X raised to 1 upon 2 bracket raised to 4 means what x square. Therefore, dy by dx is equals to 2x. And this is answer. Now next is seventh one. Question number 7. Differentiate the following with respect to x. That is, here we will apply the rules. Differentiate the following with respect to x. Y is equals to cot inverse of cot of e raised to x square. That is nothing but cot inverse of cot of e raised to x square is nothing but the e raised to x square, and derivative of e raised to x square is e raised to x square into derivative of x square is 2x. This is very simple. E raised to x square into derivative of x square is a 2x. Therefore, dy by dx is equals to e raised to x square, 2x into e raised to x square. Next is 2x into e raised to x square. Third, y is equals to cos inverse in root of 1 plus cot. Second one, this is not the third. Y is equals to cos inverse 1 upon cos of phi raised to x. It becomes sec of phi raised to x. And this sec can be converted into the cosec by pi by 2 minus phi raised to x. And that's why y is equals to pi by 2 minus phi raised to x. And it's a derivative, pi by 2. Derivative of pi by 2 is 0. Phi raised to x is phi raised to x into log of phi. This is again very simple. And see this here. Now see this here. E raised to x square. So derivative is simple. Derivative of e raised to x square is e raised to x square into derivative of x square is a 2x. And next is a cosec inverse of 1 upon cos of phi raised to x. It becomes sec. And sec can be converted into the cosec, pi by 2 minus phi raised to x. Y is equals to pi by 2 minus phi raised to x. Therefore, dy by dx is equals to minus phi raised to x into log of phi. And hence the answer. Now the next is third one. That is y is equals to cos inverse in root of 1 plus cos x upon 2. Therefore, 1 plus cos x means what? 2 cos square x upon 2. This 2 get cancelled. You will get cos inverse of cos of x upon 2. That is a x upon 2. Differentiate this with respect to x. Therefore, dy by dx is equals to 1 upon 2. See this again here. Y is equals to 1 plus cos x. That is a 2 cos square x upon 2. This 2 get cancelled. You will get y is equals to cos inverse of cos of x upon 2. Square and root sign. 2 get cancelled. Cos of x by x upon 2. Derivative of x is 1. That is 1 upon 2. The problem number 5. Y is equals to tan in. Y is equals to cos inverse in root of 1 minus cos of x square upon 2. That is it. Y is equals to cos inverse. That is a 2 sine square, whatever that x square upon 2. This 2 get cancelled. Cos inverse of sine of x square upon 2. Now this sign can be written as cos of pi by 2 minus x upon 2. That is y is equals to pi by 2 minus x square upon 2, and it's a derivative. The derivative of pi by 2 is 0 and x square is a 2x upon this 2 get cancelled. You will get dy by dx is equals to, therefore dy by dx is equals to minus 1. Dy by dx is equals to minus x. Again, see this here. This 2 get cancelled, square and root get cancelled. Then y is equals to cos inverse of cos of pi by 2 minus x upon 2. Therefore, dy by dx is equals to derivative of x square is a 2x upon 2. Dy by dx is equals to minus x. Now the next is fifth one. Y is equals to tan inverse of 1 minus tan of x upon 2 upon 1 plus tan of x upon 2. Therefore, tan inverse of 1 means what? Pi by 4. And this is nothing but the expansion of tan of pi by 4 minus x upon 2. Therefore, y is equal, that is a tan inverse of tan of pi by 4 minus x upon 2 is a pi by 4 minus x upon 2. And the derivative of pi by 4 minus x upon 2 is the 0, 1 and a minus 1 upon 2. This is the result. The next is, again, see this here. This 1 means what? The pi by 4 into pi by 4. This is the expansion of tan of pi by 4 minus x upon 2. That is the tan inverse of tan of pi by 4 minus x upon 2 is nothing but pi by 4 minus x upon 2. Now differentiate 0 minus 1 upon 2. Therefore, dy by dx is equals to minus 1 upon 2. Y is equals to cosec inverse 1 upon 4 cos cube x cos cube 2x minus 3 cos of 2x. Now this is the expansion of cos of 3x, that is a 3 into in bracket 2x. This is. Now this cos of 3 in bracket 2x, that is a cos of 6x. It's a converted into sec inverse of sec of 6x. And again it is a converted into the cosec. Y is equals to cosec inverse in bracket cosec of 6x pi by 2 minus 6x, and that is equals to y is equals to pi by 2 minus 6x. Now differentiate this with respect to x. dy by dx is equals to minus 6. Now see this again. This is a 6x, this is a reciprocal. Again convert cosec pi by 2 minus and y is equals to pi by 2 minus 6x. Differentiate this with respect to x. dy by dx is equals to minus 6. Hence the answer. Now the next is y is equals to tan inverse of 1 plus cos of x upon 2 upon sin of x upon 3. That is a tan inverse of 2 cos square, whatever that angle divided by 2. That is x upon 6. And sin of x upon 3 means what? 2 times sin of x upon 2. 6 into cos of x upon 6. For 1 cos get cancelled, you will get cos of x upon 6 upon sin of x upon 6. That will be cot of x upon 6. That is y is equals to tan inverse of cot of x upon 6. And this cot can be converted into the tan. Y is equals to tan inverse of tan of pi by 2 minus x upon 6. And the answer is that is y is equals to tan in pi by 2 minus x upon 6. There is 0. That is minus 1 upon 6. This is the dy by dx. Now, you can see this also. Dy by dx is equals to minus 1 upon 6. See this here. One plus cos of x upon cos get cancelled, you will get cot. Cot is converted into the tan, and that is equals to minus 1 upon 6. Now the next is eighth one. Y is equals to cot inverse of sin of 3x upon 1 plus cos of 3x. Sin of 3x means what? 2 sin of 3x upon 2 into cos of 3x upon 2. That is a 2 cos square 3x upon 2. 1 cos get cancelled, 2 get cancelled. You will get cot inverse of that is a cos get cancelled. Then you will get cot inverse of tan of 3x upon 2. Cot inverse of cot of pi by 2 minus 3x upon 2. And that is equals to y is equals to pi by 2 minus 3x upon 2. Therefore, dy by dx is equals to the derivative of pi by 2 is 0 and 3x upon 2 is a derivative of x is 1. That is a minus 3 by 2 into 1. That is a minus 3 by 2. Next is sin of 3x, that is a 2 sin of 3x upon 2 cos of 3x upon 2. 1 plus cos of 3x means what? 2 cos square 3x upon 2. That is y is equals to cot inverse of this 2 get cancelled. 1 cos get cancelled, you will get tan of 3x upon 2. This tan can be converted into the cot, that is the cot of pi by 2 minus 3x upon 2. Y is equals to pi by 2 minus 3x upon 2. It's a derivative. Is a dy by dx is equals to minus 3 by 2. Now the next is y is equals to tan inverse of cos of 7x upon 1 plus sin of 7x That is a cos square 7x upon 2 minus sin square 7x upon 2. And to the denominator, that is the cos of 7x upon 2 plus sin of 7x upon 2 bracket square. Now split up this. Plus term will get cancelled. You will get cos of 7x upon 2 minus sin of 7x upon 2 upon cos of 7x upon 2 plus sin of 7x upon 2 bracket complete. Divide n and dy cos of 7x upon 2. Then you will get 1 minus tan of 7x upon 2 upon 1 plus tan of 7x upon 2. And this is nothing but the y is equals to tan inverse of tan of pi by 4 minus 7x upon 2. That is y is equals to tan inverse, that is a pi by 4 minus 7x upon 2. And differentiate with respect to x, therefore dy by dx is equals to minus 7 upon 2. The same thing is here. See this, how it is. 7x, that is a cos square 7x upon 2 minus sin square 7 upon 2. There is a square, plus sign will get cancelled, 1 power is get cancelled. Divide n and dy cos of 7x upon 2, you will get 1 minus tan of 7x upon 2 upon 1 plus tan of 7x upon 2. This is tan of pi by 4 minus 7x upon 2. That is y is equals to pi by 4 minus 7x upon 2. Derivative of x is 1 minus 7 upon 2. Derivative of pi by 4 is 0. And this is the answer. Now next is that is y is equals to tan inverse of in root of 1 plus cos x upon 1 minus cos x. Y is equals to tan inverse 1 plus cos x upon 1 minus cos x bracket complete. There is a tan inverse of, that is a 2 cos square x upon 2 upon 2 sin square x upon 2. This 2 get cancelled. You will get tan inverse of in root of cot x, cot square x. Square and root sign get cancelled. That is a tan inverse of tan of pi by 2 minus x upon 2. Therefore, you will get y is equals to pi by 2 minus x upon 2. And it's a derivative. That is the derivative of 0 minus 1 upon 2. Dy by dx is equals to minus 1 upon 2. Next is the same thing is here again. Explain y is equals to, by the formula, this is a cot, convert it to the tan, find out the derivative, which is minus 1 upon 2. Now next is 11. Tan inverse of cosec x plus cot x. That is the tan inverse of cosec x plus cot x can be simplified now. That is a cosec x means what? 1 upon sin x. And cot means what? Cos of x upon sin x. That is 1 plus cos x upon sin x. Y is equals to tan inverse of 1 plus cos x upon sin x. Now this 1 plus cos x is written as 2 cos square x upon 2. And sin x is 2 sin x by 2 into cos x by 2. Therefore 1 cos get cancelled, 2 get cancelled, tan inverse of cot of x upon 2. And that is y is equals to tan inverse of cot of x upon 2. This cot can be converted into the tan, that is a tan inverse of tan of pi by 2 minus x upon 2. And that is equals to y is equals to pi by 2 minus x upon 2. Therefore, dy by dx is equals to minus 1 upon 2. Now, again you can see this here. Cosec x plus cot x, 1 upon sin x plus cos x upon sin x. 1 plus cos x upon sin x, 2 cos square x upon 2. Sin x means what? 2 sin x by 2 into cos x by 2. 1 cos get cancelled. Cos of x upon 2, sin of x upon 2, cot of x upon 2. Cot is converted into the tan. That is the tan of pi by 2 minus x upon 2. That is y is equals to pi by 2 minus x upon 2, and therefore dy by dx is equals to minus 1 upon 2, and hence the answer. Now the next is hmm. 12th y is equals to cot inverse in bracket in root of 1 plus sin of 4x upon 2 plus in root of 1 minus sin of 4x upon 3 upon in root of 1 plus sin of 4x upon 3 minus in root of 1 minus sin of 4x upon 3. Now this type of the example. Therefore y is equals to cot inverse if you apply the formula, then you will get in root of cos of x by 2 cos of 2x upon 3 plus sin of 2x upon 3 bracket square. Here is also cos of 2x upon 3 minus sin of 2x upon 3 bracket square and root get cancelled. Same thing for the denominator. That is the cos of 2x upon 3 plus sin of 2x upon 3 bracket square minus cos of 2x upon 3 minus sin of 2x upon 3 bracket square and root get cancelled, and that's why you will get cot inverse of cos of 2x upon 3 plus sin of 2x upon 3 plus cos of 2x upon 3 minus sin of 2x upon 3. Therefore in root of cos of 2x upon 3 plus sin of 2x upon 3 minus cos of 2x upon 3 plus sin of 2x upon 3. Now the terms get cancelled. Therefore you will get cos of 2x upon 3 upon sin of 2x upon 3. That is nothing but cot of 2x upon 3, and which is required. Next is therefore y is equals to 2x upon 3. It's a derivative of x is 1. Therefore dy by dx is equals to 2 upon 3. Dy by dx is equals to 2 upon 3, and hence the answer. This is the formula that you can see this. This is important. Once you get it's a cot and it's a derivative is a 2 upon 3. Now the next is now the question number 8. Differentiate the following with respect to x. Therefore now y is equals to sin inverse of 4 sin x plus 5 cos x upon root of 41. The same triangle is drawn in the short examples we have seen this here. Sin inverse of 4 upon root of 41 sin x plus 5 upon root of 41 cos x. Therefore in triangle 90 ABC alpha 4 root of 41 5. That is the sin of alpha is equals to 4 upon root of 41. Cos of alpha is equals to 5 upon root of 41. Cos of alpha is 4 upon root of 41. Sorry. Sin of alpha is equals to 5 upon root of 41. And therefore y is equals to sin inverse of cos alpha into sin x plus sine alpha into cos x, and that is nothing but y is equals to sine inverse of sine of x plus alpha. That is a sine inverse of y is equals to x plus alpha. It's a derivative is 1, dy by dx is 1. Again, if you want to see this, yes, the same thing that we have done. This is now the next is y is equals to cos inverse in root cos inverse of root of cos of 3x minus sin x upon 2. That is y is equals to cos inverse. Separate it. Root 3 upon 2 into cos x minus 1 upon 2 into sin x. ABC is a triangle. The first is 1, 2, root 3. Cos of alpha, root 3 upon 2. Sin of alpha, 1 upon 2. Therefore, y is equals to cos inverse. Cos of alpha, cos x minus sin of alpha, sin x. And this is the expansion of y is equals to cos inverse. That is the cos of x minus alpha. Therefore, y is equals to x minus alpha. It's a derivative. Derivative of x is 1, divided by x is 1. Now see this here, same here, second one. Where x is equals to 1. Now the next is third one. Y is equals to sine inverse of cos root x plus sine root x upon root 2. That is y is equals to sine inverse 1 upon root 2 cos of root x plus 1 upon root 2 sine of root x. That is 1 upon root 2 means what? That is pi by 4. 1 root 2 alpha. 1 upon root 2 means alpha. That is 1 upon root 2. Cos of alpha is also 1 upon root 2. And y is equals to sine inverse of sine of alpha cos of root x plus cos of alpha sine of root x. Sine inverse of sine of root x plus alpha. That is a y is equals to root x plus alpha. It's a dy by dx is equals to 1 upon 2 times root x. One upon 2 root x, and derivative of alpha is 0. Therefore, dy by dx is equals to 1 upon 2 root x. This is the answer. Now see this again. Separate it. Y is equals to root x plus alpha. It's a derivative. Dy by dx is equals to 1 upon 2 root x. Hence answer. Now the next is number 4. Y is equals to cos inverse in bracket 3 cos of 3x minus 4 sin of 3x upon 5. Y is equals to cos inverse, that is 3 by 5 cos of 3x minus 4 upon 5 sin of 3x that is a 3 by 5 ABC alpha, that is a 3 by 5 means what? Cos of alpha, that is in square bracket we must have the cos, expansion of the cos, that is the cos of alpha is equals to 3 by 5, sin of alpha is 4 by 5, y is equals to cos inverse cos of alpha into cos of 3x minus sin of alpha sin of 3x, y is equals to cos inverse, and that is the expansion of cos of 3x minus alpha, therefore its derivative is dy by dx is equals to 3. Next is say this here, this is the y is equals to 3 by 5, 4 by 5 and dy by dx. Now the next is fifth one. Y is equals to cos inverse 3 cos of e raised to x plus 2 sin of e raised to x upon root of 13. That is a cos inverse in bracket 3 upon root of 13 cos of e raised to x plus 2 upon root of 13 sin of e raised to x. Therefore, ABC alpha, that is a 3 upon root 13, that is a cos alpha, sin alpha is equals to 2 upon root of 13, y is equals to cos inverse cos alpha cos of e raised to x plus sin alpha sin of e raised to x, that is y is equals to cos inverse cos of e raised to x minus alpha, y is equals to e raised to x minus alpha, differentiate with respect to x, dy by dx is equals to e raised to x, derivative of alpha is 0. Now the next is again you can see this here, this problem or that another, this is 3 upon root of 13, 2 upon root of 13. I will summarize this, and dy by dx is equals to e raised to x. Next is y is equals to cosec inverse, that is a 10 upon 6 sin of 2 raised to x minus 8 cos of 2 raised to x, and it is converted sin inverse of 6 sin of 2 raised to x minus 8 cos of 2 raised to x upon 2, that is 6 upon 10 sin of 2 raised to x minus 8 upon 10 cos of 2 raised to x, that is a 3 by 5 4 by 5. Therefore ABC, that is a 3 by 5 6 by 5 must be cos, and 8 by 10 that is a sin, that is sin inverse of sin of 2 raised to x cos of alpha minus sin of alpha and cos of 2 raised to x. Therefore, this is the expansion of y is equals to sine inverse of I think that some examples may be ups or down position. Therefore, now this is the fifth one. In the same manner, we'll solve this. Draw the triangle. Cos alpha 3 upon root of 13, sin alpha 2 upon root of 13. And that's why you will get dy by dx is equals to e raised to x. Now the next is sixth one. Y is equals to cosec inverse 10 upon 6 sin 2 raised to x minus 8 cos of 2 raised to x. That is y is equals to sine inverse of 6 sin of 2 raised to x minus 8 cos of 2 raised to x upon 10. Separate this. मला असं वाटतं एक दोन एक्झाम्पल्स वरती खाली जाणे होण्याची शक्यता आहे. ठीक आहे, यू कॅन अंडरस्टँड दिस. Therefore, now again this is also simple. Triangle ABC, cos alpha is equals to 6 upon 10, sin alpha is equals to 8 upon 10. That is sine inverse of sine of 2 raised to x into cos alpha and minus sine alpha into cos of 2 raised to x, bracket complete. Y is equals to sine inverse of, that is sine of 2 raised to x minus alpha. That is y is equals to 2 raised to x minus alpha. And that's why its differentiation is that dy by dx is equals to 2 raised to x into log of 2, derivative of alpha is 0. And that's the answer. Okay. Same thing, you can see this here also. This is the sixth one. Then y is equals to cosec inverse, convert it into the sine, draw the triangle, then you will get, I think that one more examples there will be up and down. Now we'll start the next question. That is the question number 9. Differentiate the following with respect to x. Now here we will apply the substitution methods. This is important. Y is equals to cos inverse in bracket 1 minus x square upon 1 plus x square. Put x is equals to tan theta. Therefore, theta is equals to tan inverse of x. Therefore, y is equals to cos inverse in bracket 1 minus tan square theta upon 1 plus tan square theta. That is y is equals to cos inverse of cos of 2 times theta. That is equals to 2 theta. Therefore, theta is equals to tan inverse of x, and hence dy by dx is equals to 2 upon 1 plus x square. Now the next is now see this again. y is equals to, put x is equals to tan theta. Theta is equals to tan inverse of x. Y is equals to cos inverse 1 minus tan square theta upon 1 plus tan square theta. Cos inverse of 2 times theta, that is equals to 2 theta. 2 tan inverse of x divided by x is equals to 2 upon 1 plus x square. Now the next is y is equals to tan inverse of 2x upon 1 minus x square. Now this is the, put x is equals to tan theta. Theta is equals to tan inverse of x. Therefore y is equals to tan inverse of 2 tan theta upon 1 minus tan square theta. That is the tan inverse of tan of 2 times theta. That is equals to 2 theta. But what is the theta? Theta is the tan inverse of x. Now differentiate this with respect to x. That is the dy by dx is equals to 2 upon 1 plus x square. See this here. This is to put x is equals to tan theta. Now the next is for example sin inverse of in bracket 1 minus x square upon 1 plus x square. Put x is equals to again tan theta. Very important substitutions are theta is equals to tan inverse of x. Therefore y is equals to sin inverse in bracket 1 minus tan square theta upon 1 plus tan square theta. Therefore y is equals to sin inverse of in bracket cos of 2 times theta. And this cos of 2 times theta can be converted into the sine. That is the sin inverse of sine of pi by 2 minus 2 theta. That is equals to pi by 2 minus 2 theta. Now differentiate this with respect to theta. That is substitute the value of theta, that is a tan inverse of x. Dy by dx is equals to minus 2 1 upon 1 plus x square. Therefore this is the dy by dx. Again see this here. For example, put x is equals to tan theta. Therefore you will get 1 minus tan square theta upon 1 plus tan square theta cos of 2 times theta. Convert it. Sin of pi by 2 minus 2 theta. Y is equals to pi by 2 minus 2 theta. Therefore you will get, that is a 2 tan inverse of x. It's a derivative. Dy by dx is equals to minus 2 upon 1 plus x square. Next is y is equals to sin inverse 2x in root of 1 minus x square. Put x is equals to sin theta. Theta is equals to sin inverse of x. Y is equals to sin inverse, that is a 2 sin theta in root of 1 minus sin square theta, which is a cos theta. Y is equals to sin inverse 2 sin theta into cos theta. That is nothing but the sin inverse of sin of 2 times theta, which is equals to 2 theta. But what is the theta? Theta is the sin inverse of x. Now differentiate this with respect to x. Therefore you will get dy by dx is equals to 2 upon in root of 1 minus x square. Next is, that is a correction in the answer. See this here. Y is equals to 2 theta. This is the 2 upon in root of 1 minus x square. Now the next. That is y is equals to cos inverse in bracket 3x minus 4x cube. Put x is equals to cos theta. Theta is equals to cos inverse of x. Therefore, y is equals to cos inverse of 3 cos theta minus 4 cos cube theta. That is a cos inverse of, take minus sign as a common. This is 4 cos cube theta minus 3 cos theta. That is a cos of 3 theta. That is a cos inverse of cos of 3 theta. And this is nothing but the, well, that is a pi by this is the y is equals to pi minus cos inverse of cos of 3 theta. Therefore, that is a y is equals to pi minus 3 theta. Differentiate this, theta is equals to cos inverse of x dy by dx is equals to minus 3 minus 1 upon in root of 1 minus x square, and minus plus here dy by dx is equals to, and here is also the correction in the answer. This is the answer. Okay. Now the next is same thing is here. Y is equals to cos inverse of minus cos of 3 theta, pi minus cos inverse of cos of 3 theta, and that's why you will get the answer. Next is sixth one. Y is equals to cos inverse e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x. Now again here cos inverse e raised to x minus 1 upon e raised to x plus 1 upon e raised to x. Therefore, cos inverse of, it is a e raised to 2 e raised to 2x minus 1 upon e raised to 2x plus 1. Again we will take the minus sign as common, then in bracket you will get 1 minus e raised to 2x upon 1 plus e raised to 2x. Now put the e raised to x is equals to tan theta, and that's why you will get theta is equals to tan inverse of e raised to x. Therefore, y is equals to cos inverse minus 1 minus tan square theta upon 1 plus tan square theta, and that is nothing but the cos of 2 times theta, cos inverse of cos of 2 times theta. Again, it is a pi minus cos inverse of cos of 2 times theta. That is pi minus, I forget to write there pi, that is a 2 tan inverse of e raised to x. Therefore, its derivative is a minus 2 upon 1 plus e raised to x bracket square into derivative of e raised to x is e raised to x. Therefore, dy by dx is equals to minus 2 e raised to x upon 1 plus e raised to 2x. This is minus 2 e raised to x upon 1 plus e raised to 2x. Now see this again here. We can write this. E raised to x is tan theta. Take minus n common. Pi minus, I forget to write here pi. Here must be pi. Then after differentiation, that's just the derivative is 0. That y is equals to minus 2 tan inverse of e raised to x. And that's the differentiation is there. Now the next is y is equals to cos inverse 1 minus 9 raised to x upon 1 plus 9 raised to x. Same substitutions are that 3 raised to x bracket square upon 1 plus 3 raised to x bracket square. 3 raised to x is equals to tan x, tan theta. Therefore, theta is equals to tan inverse of 3 raised to x. Therefore, y is equals to cos inverse of 1 minus tan square theta upon 1 plus tan square theta. Therefore, dy by dx is equals to cos inverse of cos of 2 times theta. That is equals to 2 theta. Substitute the value of theta. That is the tan inverse of 3 raised to x. And it's a derivative dy by dx is equals to 2 upon 1 plus 3 raised to x bracket square into derivative of 3 raised to x. That is 3 raised to x into log of 3. That is a 2 into 3 raised to x into log of 3 upon 1 plus 3 raised to 2x. Therefore, this is the dy by dx. The same thing. See this here again. And this is the final answer. Next, eighth one. That y is equals to sine inverse 4 raised to x plus 1 upon 2 upon 1 plus 2 raised to 4x. That is y is equals to sine inverse 4 raised to 1 upon 2 into 4 raised to x. 1 plus 2 raised to 2 and bracket raised to 2x. Therefore, sine inverse of 2 into 4 raised to x upon 1 plus 4 raised to 2x. And again here we substitute, that is the 4 raised to x is equals to tan theta. Therefore, theta is equals to tan inverse of 4 raised to x. Therefore, y is equals to sine inverse of 2 tan theta upon 1 plus tan square theta. That is nothing but the tan of 2 times. That is nothing but the sine of 2 times theta. And therefore, y is equals to sine inverse of sine of 2 times theta is equals to 2 tan inverse of 4 raised to x. And it's a derivative. Differentiate this with respect to x. dy by dx is equals to 2 upon 1 plus 4 raised to x bracket square into dx of 4 raised to x. That is the derivative of 4 raised to x is a 4 raised to x into log of 4. That is a 2 into 4 raised to x into log of 4 upon 1 plus 4 raised to x 4 raised to 2x. Therefore, dy by dx is equals to 2 into 4 raised to x into log of 4 upon 1 plus 4 raised to 2x. that is a y is equals to sine inverse of 1 minus 25x square upon 1 plus 25x square. Now here the 5x bracket square, 1 minus 5x bracket square upon 1 plus 5x bracket square. That is sine inverse of 1 minus 5x bracket square upon 1 plus 5x bracket square. Put here 5x is equals to tan theta. Therefore theta is equals to tan inverse of 5x. And that's why you will get y is equals to sine inverse of 1 minus tan square theta upon 1 plus tan square theta. That is y is equals to tan sine inverse of, this is nothing but the cos of 2 times theta, and again it can be converted into the sine of pi by 2 minus 2 theta. And that is equals to y is equals to pi by 2 minus 2 theta. Therefore y is equals to pi by 2 minus 2 tan inverse of 5x. And differentiate this with respect to x. That is the derivative of tan inverse of 5x. That is 1 upon 1 plus 5x bracket square into derivative of 5x is 5. That is 5 into 2, 10. That is you will get the answer dy by dx is equals to minus 10 upon 1 plus 25x square. Now the next problems are same. That is sine inverse of in bracket 1 minus x cube upon 1 plus x cube. That y is equals to sine inverse of 1 minus x cube upon 1 plus x cube. X cube is equals to tan square theta. Therefore tan theta is equals to x raised to 3 by 2. Therefore theta is equals to tan inverse of x raised to 3 by 2. And that's why y is equals to sine inverse of 1 minus tan square theta upon 1 plus tan square theta. And that's why you will get y is equals to sine inverse of cos of 2 times theta. That is a y is equals to sine inverse of sine of pi by 2 minus 2 theta. And that is y is equals to pi by 2 minus 2 theta. What is the theta? Theta is the tan inverse of x raised to 3 by 2. Now differentiate with respect to x. Therefore derivative of pi by 2 is 0 minus 2 tan inverse of, that is 1 upon 1 plus x raised to 3 by 2 bracket square into derivative of x raised to 3 by 2. That is a 3 by 2 into x raised to 1 upon 2. This 2 get cancelled, and that's why you are getting, that is a minus 3 upon 1 plus x cube into root x. Therefore dy by dx is equals to minus 3 root x upon 1 plus x cube. Now the 11th one, that is y is equals to tan inverse of 2 into x raised to 5 by 2 upon 1 plus x raised to 5. That is, put x is equals to x raised to 5 by 2 is equals to tan theta. Therefore theta is equals to tan inverse of x raised to 5 by 2. Therefore y is equals to tan inverse of 2 tan theta upon 1 plus tan square theta. And this is nothing but the y is equals to tan inverse of tan of 2 times theta. Therefore that is equals to 2 times theta, and hence put theta is equals to tan inverse of x raised to 5 by 2. That is y is equals to 2 tan inverse of x raised to 5 by 2, and that's why its a derivative is, that is a dy by dx is equals to 2 into 1 upon 1 plus x raised to 5 by 2 bracket square into ddx of x raised to 5 by 2. Therefore that is a 2 x raised to 5 by 2 bracket square means what, 1 plus x raised to 5 into ddx of x raised to 5 by 2, that is 5 by 2 into x raised to 3 by 2. And that's why 5 into x raised to 3 by 2 upon 1 plus x raised to 5. Therefore this is the dy by dx is equals to 5 into x raised to 3 by 2 upon 1 plus x raised to 5. The same type of the problems are repeated here. That y is equals to cot inverse of in bracket 1 minus root x upon 1 plus root x, and that is equals to y is equals to tan inverse of 1 plus root x upon 1 minus root x. Now put here root x is equals to tan theta, and theta is equals to tan inverse of root x. Therefore you will get y is equals to tan inverse of, this 1 means what, tan of pi by 4 plus tan theta upon 1 minus tan of pi by 4 into tan theta. Now this is nothing but the expansion of tan of pi by 4 plus theta, and that is a tan inverse of tan of pi by 4 plus theta, that is y is equals to pi by 4 plus theta. But what is the theta? Theta is the tan inverse of root x. Now differentiate this with respect to x. Derivative of pi by 4, whose constant is 0, and tan inverse of root x, that is the dy by dx is equals to 1 upon 1 plus a root of x bracket square into derivative of root of x, that is 1 upon 2 times root x. Therefore dy by dx is equals to 1 upon 2 root x in bracket 1 plus x. Therefore dy by dx is equals to 1 upon 2 root x into 1 plus x. Now the question number 10, this is very simple. That is y is equals to tan inverse of in bracket 8x upon 1 minus 15x square. Now this 8x can be written as 5x plus 3x upon 1 minus 5x into 3x. That is a 15x square. And this is nothing but the tan inverse of 5x plus tan inverse of 3x. Now differentiate this with respect to x. Then you will get, that is a dy by dx is equals to 1 upon 1 plus 25x square into ddx of 5x plus 1 upon 9x square into ddx of 3x. That is, you will get 5 upon 1 plus 25x square plus 3 upon 1 plus 9x square, and hence dy by dx is equals to 3 upon 1 plus 9x square plus 5 upon 25x square. Next is y is equals to cot inverse of 1 plus 35x square upon 2x. Now cot inverse of 1 plus 35x square upon 2x, this can be written as tan inverse of 2x upon 1 plus 35x square. Now again this can be written as tan inverse of 7x minus 5x, and their product is a 35, and that's why we have, that is the tan inverse of 7x minus tan inverse of 5x. Now differentiate this with respect to x. Therefore dy by dx is equals to 1 upon 1 plus 49x square into derivative of 7x minus 1 upon 1 plus 25x square into ddx of 5x, that is a 5. Therefore dy by dx is equals to 7 upon 1 plus 49x square minus 5 upon 1 plus 25x square, and that's why you will get dy by dx is equals to 7 upon 1 plus 49x square minus 5 upon 1 plus 25x square. Next is the third one, y is equals to tan inverse of 2 root x upon 1 plus 3x, and it is written as y is equals to tan inverse of 3 root x minus root x. That is, a 2 root x can be written as 3 root x minus root x, and again this 3x can be written as 3 root x into root x. That is a tan inverse of 3 root x minus tan inverse of root x. Now differentiate this with respect to again x. That is 1 upon 1 plus 3 root x bracket square into ddx of 3 root x minus 1 upon 1 plus root x bracket square minus derivative of root x, which is 1 upon 2 times root x. And here is again derivative of root x is 1 upon 2 times root x. Only the normal simplification is there. dy by dx is equals to 3 upon 1 plus 9x into 2 root x minus 1 upon 1 plus x into 1 upon 2 root x. And that's why dy by dx is equals to, that is, here we take the common, that is 1 upon 2 root x in bracket 3 upon 1 plus 9x minus 1 upon 1 plus x. Now the next problem is, that is the problem number 4. Y is equals to tan inverse of 2 raised to x plus 2 upon 1 minus 3 into 4 raised to x. Now this 2 raised to x plus 2 can be written as 2 raised to 2 into 2 raised to x. And this 4 raised to x can be written as 2 raised to x and bracket square. And again, this is the expansion of y is equals to tan inverse of 2 raised to 2 into 2 raised to x. And that is a 1 minus 3 into 2 raised to x bracket square. Therefore, again, it can be written as tan inverse of 4 into 2 raised to x upon 1 minus 3 into 2 raised to x bracket square. Now, this can be written as, that is a 3 into 2 raised to x. This is a one term plus 2 raised to x. This is another term. Their sum is 4 into 2 raised to x, and their product is 3 into 2 raised to x bracket square. And that's why we can write here, that is a tan inverse of 3 into 2 raised to x plus tan inverse of 2 raised to x. Now differentiate this. That is a 1 upon 1 plus 3 into 2 raised to x bracket square into ddx of 3 into 2 raised to x plus 1 upon 1 plus 2 raised to x bracket square into ddx of 2 raised to x. And that's why 1 upon 1 plus 9 into 2 raised to 2x into derivative of 3 into 2 raised to x. That is, 3 is as it is, 2 raised to x. Derivative of 2 raised to x is 2 raised to x into log of 2 plus 1 upon 1 plus 1 upon 1 plus 2 raised to 2x into derivative of 2 raised to x. The derivative of 2 raised to x is 2 raised to x into log of 2. And hence the answer, that is a 2 raised to x into log of 2 in bracket 3 upon 1 plus 9 into 2 raised to 2x plus 1 upon 1 plus 2 raised to 2x And that's why dy by dx is equals to 2 raised to x into log of 2 upon 3 upon 1 plus 9 into 2 raised to 2x plus 1 upon 1 plus 2 raised to 2x. Now the next is fifth one, that is y is equals to tan inverse of 2 raised to x upon 1 plus. Now this is 2 raised to 2x plus 1 can be written as 2 raised to x upon 1 plus 2 into 2 raised to x into 2 raised to x. Now see this here. That is the tan inverse of 2 times 2 raised to x minus 2 raised to x. If there is subtraction, then you will get 2 raised to x. Therefore, tan inverse of 2 into 2 raised to x minus 2 raised to x upon 1 plus 2 into 2 raised to x into 2 raised to x. And this is nothing but again tan inverse of 2 into 2 raised to x minus tan inverse of 2 raised to x. Now differentiate this with respect to x. Then again dy by dx is equals to 1 upon 1 plus 2 into 2 raised to x bracket square into ddx of 2 into 2 raised to x. That is the derivative of 2 raised to x is 2 raised to x into log of 2 and this 2 is a constant. Next is again 2 raised to x. Tan inverse of 2 raised to x means what? 1 upon, this is a 1 upon 1 plus 2 raised to x bracket square into 2 raised to x into log of 2. That is the derivative of 2 raised to x is 2 raised to x into log of 2. And therefore again we will have again common 2 raised to x into log of 2 is common, and in bracket you will get 2 raised to x into log of 2 in bracket 2 upon 1 plus 4 into 2 raised to 2x minus 1 upon 1 plus 2 raised to 2x. And that's why dy by dx is equals to 2 raised to x into log of 2 in bracket 2 upon 1 plus 4 into 2 raised to 2x minus 1 upon 1 plus 2 raised to 2x. Now the next 6 is y is equals to cot inverse a raised to x minus 6x square upon 5ax. Now this can be converted into tan inverse of 5ax upon a square minus 6x square, and that is equals to y is equals to tan inverse 5ax upon a square minus 6x square. Now here divide n and d by a square, then you will get tan inverse of 5x upon a upon 1 minus 6x square upon a square. Now 5a upon x can be written as 3x, 5x upon a can be written as 3x upon a plus 2x upon a, and 6x square upon a square can be written as 3x upon a into 2x upon a. That is a tan inverse of 3x upon a plus tan inverse of 2x upon a. And differentiate this with respect to x. Therefore, it's a derivative. That is a dy by dx is equals to 1 upon 1 plus 3x upon 2 bracket square into ddx of 3x upon a plus 1 upon 1 plus 2x upon a bracket square into ddx of 2x upon a. And that's why you will get dy by dx is equals to 1 upon 1 plus 9x square upon a square into derivative of 3x upon a, that's a 3 upon a, plus 1 upon 1 plus 4x square upon a square into derivative of 2x upon a, which is 2 upon a. And after the simplification, you will get dy by dx is equals to a square upon a square plus 9x square into 3 upon 2 plus a square upon a square plus 4x square into 2 upon a. And that's why dy by dx is equals to, this is the 3a upon a square plus 9x square plus 2a upon a square plus 4x square. Now next is 7th one, that y is equals to tan inverse of a plus b tan x upon b minus a tan x. Now again divide, this is a b, therefore divide n and d by b. Therefore you will get y is equals to tan inverse of a upon b plus tan of x. If you divide b, this b get cancelled. This is upon 1 minus a upon b tan x. Now again, this is the tan inverse of a upon b plus tan inverse of tan of x. But what is the tan inverse of tan of x? This is x. Therefore, y is equals to tan inverse of a upon b plus x. Now differentiate this with respect to x. Same type of the problems are repeated here. Its a derivative is 0 and derivative of x is 1. Therefore, dy by dx is equals to 1. Therefore, dy by dx is equals to 1 here. Now the next is 8th one. This is the y is equals to tan inverse of 5 minus x upon 6x square minus 5x minus 3. Now y is equals to tan inverse of 5 minus x, 6x square minus 5x minus 3. Now this can be written as tan inverse of 5 minus x 1 plus 6x square minus 5x minus 4. There is a plus 1 and minus 4 that become minus 3. Here is we have adjusted for the tan inverse. Here is always one term is present here. Therefore, tan inverse of 2x plus 1 minus 3x minus 4 upon 1 plus 2x plus 1 into 3x minus 4. And this is nothing but the y is equals to tan inverse of 2x plus 1 minus tan inverse of 3x minus 4. Therefore, differentiate this with respect to x. That is dy by dx is equals to 1 upon 1 plus 2x plus 1 bracket square into ddx of 2x plus 1 minus 1 upon 1 plus 3x minus 4 bracket square into ddx of 3x minus 4. And that is nothing but 2 upon 1 plus 2x plus 1 bracket square minus 3 upon 1 plus 3x minus 4 bracket square. And that's why dy by dx is equals to 2 upon 1 plus 2x plus 1 bracket square minus 3 upon 1 plus 3x minus 4 bracket square. And the ninth one, that is y is equals to cot inverse 4 minus x minus 2x square upon 3x plus 2. That is a tan inverse of 3x plus 2 upon 4 minus x minus 2x square. Now again this can be written as, that is here is a 1, then minus in bracket 2x square plus x minus 3. Now factorize this. If you take the factors of this, then you will get the factors 2x plus 3 plus x minus 1. The main key of this problem is that to factorize this, take 1 first of all, minus sign common, then whatever that in bracket you are getting, that is a 2x square plus x minus 3, factorize this, then one factor is here and one is here. Therefore y is equals to tan inverse of 2x plus 3 plus x minus 1 upon 1 minus in next bracket 2x plus 3 into x minus 1. Therefore y is equals to tan inverse of 2x plus 3 plus tan inverse of x minus 1. Now differentiate this with respect to x, that is a dy by dx is equals to 1 upon 1 plus 2x plus 3 bracket square into ddx of 2x plus 3 plus 1 upon x minus 1 bracket square into ddx of x minus 1. And that's why you are getting dy by dx is equals to 2 upon 1 plus 2x plus 3 bracket square, and derivative of this 2x is a 2 plus 1 upon 1 plus x minus 1 bracket square. And in this way we have completed this biggest exercise, that is exercise 1.2. Now we'll see in the next video. Till then, goodbye.